Hello.
ఆన్ చేసింది 3722. హలో హలో 1 2 3 4 5 6.
నేను హోస్ట్ లో ఉండవా?
ఉంటా ఉంటా ఉంటా.
నా వాయిస్ వస్తుందా?
మెల్ల మెల్ల. అరే ఏందమ్మా ఈమె ఎంత ఎంత గట్టిగా మాట్లాడుతావు? వస్తుంది వస్తుంది, మెల్లగా మాట్లాడమ్మా, ఆఫీసర్లు వస్తారు. హలో రైల్నెట్, రైల్నెట్. హలో రైల్నెట్. హలో చెక్ 1 2 3 3 2 1.
వాయిస్
టుడే
వస్తుందా?
డేట్ టూ 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 1 minute లైవ్ స్ట్రీమ్ ఇచ్చినాను, నువ్వు మాట్లాడకు. టుడే డేట్ 37/2022. హలో చెక్ 1 2 3 3 2 1. టుడే డేట్ 37/2022.
एक तो आ रहा है मैं बाकी दूसरों का हाँ गुड मॉर्निंग सर हाँ ये मेरी वो लिंक तो भेज दिया डेलीगेट लिंक ओके सर ओके नहीं अभी तो सब ज्वाइन कर रहे हैं मिस्टर शंकर है ज्वाइन और वाइस myself and Dividista we are already there and divine karna okay sir okay
Good morning, sir. Ramnath, sir.
hello okay hello
Good morning, sir. Ramnath, sir.
good morning. So, Shanakumari madam is on the way. She is coming. And our PCST Divedi sir is also there. And I have reminded Saxena sir. He is again joining, already has joined. हाँ मैं सबको बता दिया एक दफे अगेन आई एम टेलिंग
फोटो लेकर बेटा కొంచెం ఇప్పుడు వచ్చేసింది
ఇవన్నీ తీసే
लिंक की से पड़ी थी देखो रेलवे की you can locally, you can directly.
Good morning. Hey, Betty. Manikumar. ये प्रेजेंटेशन क्या इसमें शेयर कर दिया है क्या?
नहीं है सर,
शेयर नहीं किया ना?
नहीं शेयर नहीं किया।
नंबर कर देंगे। ये सारा इसमें बताता हूँ। ये वाला जो है ना, ये मैं दे दे रहा हूँ, इसको आप शेयर कर देना नॉर्मल पर्सन। ठीक है, छोड़ दीजिए। हाँ,
थोड़ा मक्खी है। हाँ, वो जो भेजा है, just join.
हाँ, यहाँ लगा दीजिए।
Hello, sir. Excuse me, sir. My screen is visible, sir.
Yes, visible.
Okay, sir. Thank you, sir.
Ladies and gentlemen, and participants who have joined this webinar for the workshop on RAMS in railways through our Webex link. I am G.K. Dwivedi, PCST South Central Railway and President of IRST India. We, in collaboration with IEEE Hyderabad Reliable Society, planned to host this workshop, which is most relevant topic as of now, as far as our working and projects executions is concerned. And I hope that joining hand with the experts in the field, it will be a wonderful opportunity for all of us to learn the nitty-gritties of the RAMS, which oftenly we are hearing only for the name, but we have not gone into the details. This workshop is lined up with 5 presentations, but at the last moment I have been told that one of the presentation will not be there. But anyway, we will be having sufficient matter to discuss and deliberate the topics which we have chosen and hear the experts in the field.
Okay, you can go. We have started.
Now, without not taking much time, I would like to invite my SST
Okay, fine.
planning, Mrs. Firdaus Khan, to take over and organize the workshop. Thank you.
Thank you, sir. Good morning, senior officers, esteemed guest speakers, colleagues, and my dear friends. I welcome you all to today's webinar on topic RAMS in Railways, which is jointly being organized by IEEE Reliability Society, Hyderabad, and IRST Secunderabad chapter. Today, We are very fortunate to have ensemble of industry experts from the area to deliver lectures to us. Firstly, I'd like to ask Dr. V. Shankar, who is PhD from IIT Delhi and has several international publications to his credit, and is also current Vice Chair, IEEE Reliability Society, Hyderabad, to deliver his welcome address.
Yeah. Thank you, madam. Am I audible to you, madam?
Yes, sir. Yes, sir. You're audible.
Yeah, thank you. Yeah. At the outset, I feel privileged to be associated event RAMS in railways. RAMS means reliability, availability, maintainability, and safety aspects. Organized by IEEE Hyderabad Section Reliability Society Chapter at Institute of Railway, Signal and Telecommunication Engineering, Rail Nilayam, Hyderabad. I take this opportunity to welcome you all, the concerned, Chair of IEEE Hyderabad Section Reliability Society Chapter, Sri Arun Saxena Garu, IRSSC, General Manager, Dr. Ajit Pandey, Head of the System Assurance, RAMS L&T Technology, Bengaluru, Sri Rajesh Patel, ISA and Railway RAMS Consultant and Chief RAMS Engineer, and members Metro Line 3, Sri Shintu Joseph, Asian Head of LDRA Bangalore, Dr. Veeramao Gargama, Reliability Center from IIT Kharagpur, Dr. Swarnabai, Secretary of IEEE Hyderabad Section Reliability Society Chapter and working in DRDO organizations, Dr. D. Ravi Kumar, Treasurer of IEEE Hyderabad Section Reliability Society Chapter, and my Guru like other executive committee members, Dr. Al Subramanian Sir, retired professor from IIT Delhi in energy systems area and power system reliability, Dr. PCH Anil Kumar and Dr. J. Srinivasu of the executive committee members of the IEEE Reliability Society Chapter, and Dr. S. Kumar from DRDO Hyderabad, who is also keen in developing this reliability engineering subject in various academic and industry environment, and other distinguished audience. I welcome you all to this particular session. I would like to briefly discuss about IEEE Hyderabad Section Reliability Society Chapter and importance of the RAMS and the MTech course that is being offered in South India through first of its standard JNTVA. I have the privilege of saying that. Now about IEEE, it is started in there 1884 in New York, spread out now 160 countries, with 334 sections, and it is under council. We have got IEEE India Council at Bangalore headquarters, and few thousand subsections are there. We have got another 4 subsection, and others like that, Guntur subsection like that, and crossed 4 million members, which includes life fellow members, life senior members, members, associate members, and it publishes 40 journals which are worldwide reputed and having several professional societies. One of the professional society is Reliability Society, and we have got Hyderabad chapter here. Reliability Society has been initiated on 12th September 21, inaugurated on 23rd October, and which is the first one in India itself, and 11th in Asia, and 31st in the world. The objectives are to promote the reliability, quality, and safety culture issues in India in the region 10. Region 10 is essentially Asia Pacific region. To promote the Reliability Society chapter in student branches and in the Hyderabad section subsequently, to strengthen the activities of the Hyderabad section activities. And about RAMS, briefly I would like to mention, as I just categorically stated, RAMS means reliability, availability, maintainability, and safety. And I have been engaged in teaching system reliability concepts and authored the book on the same title, System Reliability Concepts. And reliability is essentially the probabilistic prediction of an event, which is a chance of occurring successfully over a specified period of time for the desired level of performance. So there are various aspects in this, related to various fields. Then every industry, organization, product design, manufacturers need reliability analysis. Availability is a long-term prediction of the probability being in an operating state of a particular component or a system for a particular at the end of the period of time. Maintainability is the order of the day. We have to maintain the systems or subsystems. We have got proactive or reactive maintenance strategies, and most important one is also is risk assessment, risk management, risk prioritization, etc. And in software sector also, I got the applications like verification and validation, etc. And software reliability is also one of the important aspects. So like that, it's a multidisciplinary area. It's not confined to only one particular discipline. So regarding safety, safety is one of the most important in designing buildings, industries, prevention of the disorders or prevention of the natural calamities or mitigation of the hazardous nature of the, we know from the engineering point of view, thermal pollution, prevention of the electric shocks or earthquakes, all these things have to be studied from the probabilistic point of view, and already a lot of literature is being there in this particular aspect. And more important, so human safety is another important aspect where our chair, Somnath Balgaru, has been having collaboration, and we have framed the course structure and syllabus. Those who are interested, we can send it to them. Human errors and safety aspects in industries. Syllabus is being framed as per the DC Washington Accord. That is having the course objectives, learning outcomes, and course outcomes, which can be offered as an open elective subject, open elective course. And just 2 minutes I need to mention about the MTech Reliability Engineering course, which is started in the year 2018, 2008-9. And I know that in 2008-9 in JNTUA, where I was working in different capacities during those days. Now I am retired and working in Srinivas Raman Institute of Technology as Dean of Academics. And this is a multidisciplinary area. And I know 4 decades ago, IIT Kharagpur has started MTech Reliability Engineering course, which is still actually participating. They are having high-end research also they have been doing. And it's a multidisciplinary area which is being offered in JNTUA for any branch of engineering. And the qualified students can get jobs in the specified areas of quality engineers, reliability programmers, software reliability engineers, life testing engineers of the components and product design engineers in quality control departments and the reliability and quality assurance departments, and more so, people with having industrial experience of 8 years can take the certified reliability engineers as a authentic certified reliability engineers. So that is the advantage of this one. And so with these few words, I thank the authorities for giving an opportunity for me for addressing you towards the welcoming address and briefly mentioning about the IEEE Hyderabad Section Reliability Society Chapter, RAMS, and the Reliability Engineering course. I hope this workshop will pave the way for the above specific objectives in the railway sector also. Thank you very much. Those concerned for giving this opportunity.
Thank you, sir. Thank you, sir, for outlining the importance of RAMS and also telling us about the Reliability Society. It was very insightful. Now, I would welcome Shri Arun Saxena, sir, who is 1978 batch officer, IRSSC, and is currently consultant to Minister of Railways, and he's also ex-GM NCR. Sir is a pioneer in fail-safe brake interface and electronic interlocking over Indian Railways. I would welcome sir to deliver his keynote address.
Good morning, everybody. Am I audible?
Yes, sir, you're audible.
Good morning to everybody, all of you. Let me first of all compliment the organizers, the IEEE Reliability Society and the IRST Secunderabad chapter for organizing this very relevant workshop on RAMS for railways. And RAMS for railways is very, very relevant because we primarily focus, and that is our hallmark, that the safety in operations has to be of the highest order. And precisely for that reason, we, especially in the signaling department, have special focus on this concept of RAMS. So let me first of all address, I'd like to formally welcome and thank Mr. D.K. Dwivedi, who is the Principal CST of South Central Railway, Mr. Somnath Pal, who is the chairperson of the IEEE RS of Hyderabad region, and maybe the first such chapter in India. That is a very big event. And I'd like to thank Dr. V. Shankar, who has been some kind of an expert on reliability engineering. Other participants, delegates, galaxy of experts and professionals who are attending the session. Welcome all. I would like to take you back to my days when I started my career in the Department of Space. And this concept of RAMS was started at that stage. All of you know that in the case of a satellite, you cannot just maintain the satellite in the space. You just cannot. And therefore, the concept of RAMS started from there. But later on, I moved to the railways. And in the railways, when we moved into the railways, it was quite a shock for us, that because we were having largely mechanical and electromechanical systems. And those electromechanical and mechanical systems were primarily focused on fail safety. Nobody ever thought about the concept of MTBF or MTTR at that stage, maybe about 35, 40 years back, that we also had need to focus on the concept of RAMS. But primarily, it was the fail-safe concept. Gradually, the concept moved towards fault tolerance and safe enough. And that precisely the principle of alarm, which is called as the risk has to be as low as reasonably practicable. This concept found space into our systems gradually as we moved from electrical to electronic systems, and especially to software embedded systems. Now, as Dr. Shankar just mentioned, it is not only for signaling, it is for all the disciplines. And that is an area which we have to explore substantially, because in the area of rolling stock and track and OHE, the concept of RAM is missing to a very large extent. Mean time to repair. And these are the very important concepts. So coming back to the signaling, the mechanical signaling systems were robust in design, and they used a physical property to ensure safety. All of us know about it, the physical properties of the compensator, the semaphore arm, the relays. There's a physical property which ensures safety there. And that precisely was the base for ensuring safety at that point of time. And at that point of time, we were only primarily focusing on preventive maintenance as well as repairing as fast as possible. Later on, as we moved towards the electrical systems and the electronic system, the concepts of RAMs became increasingly important. And I would say that when we started the electronic software embedded systems in the year 1993 or so, I remember that we did the first safe lock in this country, and the first experience of the real RAMs started at that time. We talked about the concept of code walkthrough for the entire application of the safe lock. I think Mr. Pal also was involved in that activity at that stage also. And then we commissioned the first Indian indigenous safe lock in India at Duskeda in Central Railway. That was the first experience on the concept of RAMs. Now, if you look at RAMs from the angle of the layman, it is basically we are first of all trying to monitor the fault. That is, how tolerant are we to the fault? And then we have mechanisms for fault avoidance. That how can we avoid a fault? And then in case the fault takes place, then we are having techniques of predictive prediction also, that we sense the data and predict that this could be a fault, and we can even eliminate a fault. And in the worst case, if the fault takes place, then we have to focus on the concept of
removal of the fault and restoration of the system. Now, each of these are ingrained in the system, which is RAMS. Now, when you talk about the initial failure rate, that is MTBF, which is reliability. When we go into the concept of A, which is availability, which is the most important concept in my opinion, availability for operations, because that is the thing which matters ultimately. Third one is the maintainability, which is how you are able to maintain a system very fast. There are many systems which are very good, but doing it. So therefore, maintainability definitely built in design along with reliability as well as safety. These three matters: reliability, safety, and maintainability are built in the design of the system. So this will have to be very carefully looked at from that angle by all the professionals in the field who are handling the systems. Now coming to the thing which is under the control of all the maintenance officials in the field is the availability. Availability, I think all the professionals know about it. The availability is basically the ratio of MTBF divided by the total time. And this has to be 99.99% available. So when you look at this MTBF divided by MTBF plus MTTR, this is precisely the formula of operational availability. Now, if you look at the MTBF is largely intrinsic in design, and at the time of installation, we are built into the system. And therefore, that will definitely have a failure rate. All these failure rates are basically derived, especially for electronic systems and electrical systems, from the mill handbook, where the failure rates have been defined for different kinds of components used in different environments under different conditions. They have a different failure rate, and then you can work out the system MTBF based on that. But MTTR is a function of the readiness of the organization, and this readiness is dependent on the organization you got, the level of skill and knowledge they've got, the kind of tools and diagnostic systems they've got, the kind of mobility and communication they've got, and the kind of documentation they've got. If any of these is missing, your MTTR will go high. And the moment the MTTR goes high, your operational ability will go down. And therefore, our focus has to be on optimizing the MTTR, which I think all our railway officials, especially engineers in the maintenance side, are focused on MTTR. Everyone is working for MTTR only. I think these are the few words which I started with. Now coming to the specialized area of LARP. LARP, in fact, when we joined in the year 1980 or 81, we were told the system has to be fail-safe. And as I mentioned earlier, that in my opinion, the system has not to be fail-safe. It has to be safe enough, but available for operations. So it has to be fault-tolerant. And this concept must be ingrained in the minds of the people who are now designing systems for times to come, so that the systems are able to be deployed, and we are able to have a system of operations which is totally hindrance-free or failure-free. And that is the basic requirement, because nobody wants any detention to a train. Nobody, neither the management nor the user nor the passenger. And therefore, anything which fails, whether it is on the rolling stock or on the track or on the or electrical side or on the signaling side, it ultimately affects the train operations. And this has to be really controlled in a manner. And that has to be done through a systems approach, which I think the RAMS allows you to do it. Now, when we have moved towards largely software embedded electronic systems, I would like to add one more term to this RAMS. And that I've been talking for the last almost 5 to 7 years. That is called testability. And I think the world also started talking about this concept of testability. All our systems which are complex electronic systems for train detection or for the purpose of interlocking or the purpose of train control or automatic train protection, all these systems are quite complex, and they need to have systems available which are able to give proper indications to the people for testing purposes. And therefore, the testability also needs to be built in at the stage of design and installation. And this then I therefore convert the entire concept of RAMS into SMART. SMART means, first of all, it has to be safe enough, it has to be maintainable, it has to be available for operations, it has to be reliable enough, and it has to be testable. So that's why I called the concurrent breed of system, which the word, the acronym coined was SMART. And this will have to be worked on in the times to come. I think there are a lot of experts who are working in the field, especially in IT, in academics, and in the industry. They can look at it from the angle of testability. We today are struggling for testability of our systems. When we talk about the the interlocking testing, which is supposed to be done every 3 years or 5 years, there's a job to be done. And therefore, testability has to be built into the system through maintenance terminals. And obviously, in that case, the entire data has to be analyzed in a manner that you are able to detect anomalies and you are able to detect wrong side activities which can take place or which have taken place in the past, and that data can be analyzed to the systems are still left with some bug which shows up after a couple of years or a couple of months, or maybe quite almost after a decade also. That incipient bug will trouble you in the times to come. Therefore, that the system of testing has to be evolved in such embedded system. And now everything almost for almost all departments, everything is now becoming more and more software driven. Therefore, this particular aspect of safety integrity and software integrity will have to be developed. I will like to not to take much of your time because you have got 4 papers lined up and you have got to listen to them. They are experts in the area. They will be able to throw more light on these concepts of RAMS, especially from the angle of reliability, availability, and maintainability. Thank you all. And let me also tell you that one last point which I would like to mention is that we also took one initiative in this area involving the Center for Reliability Madras, Chennai. That was way back in 1993, when we did the first investigation on our access counters and followed the concept of FTA and reliability prediction. And that particular investigation suggested that there were 7 or 8 components which were not properly selected or not properly used in the required environment. And that particular area of activity, I think people normally miss it. But this is a very important activity, especially at the stage of initial design of a system or a module or a card. And therefore, this concept must be ingrained, especially in our people in RDSO or who are developing systems in the industry. This is an important area, and we have a capacity and capability available in India. And last but not the least, but I would say the most important is what Dr. Shankar mentioned about the initiatives of skill development and knowledge development. This has been happening in IIT Kharagpur for a long time. I know some of my colleagues have done MTech in IIT Kharagpur in reliability engineering. And now I think the concept of MTech in IIT is, or maybe PG diploma on reliability systems, is now spreading almost in every university in the country. We are also now starting the concept of signaling is a specialized area. We are also starting a concept of been approved by the AICT. And now the universities are gradually adopting those modules for the purpose of learning about signaling and train control, especially from the angle of automatic train protection, which is our current indigenous system, which is called the Kavach TCAS, Train Collision Avoidance Systems. So all the best for the event and best wishes to the organizers once again. Thank you all. Thank you so much.
Thank you, sir, for your address. It was very insightful. Now we have Dr. Ajit Pandey, who will deliver the lecture on RAM standard EN 50126 in mainline and metro railways. Shri Ajit Pandey is MTech Software Engineering from MNNIT Allahabad and PhD Reliability Engineering from IIT Kharagpur. He is having more than 20 years of experience in software and software engineering, system and software engineering, system insurance, and RAMS. He has worked in many MNCs like Cognizant, ACOM, Alstom, L&T, Bombardier, and Atkins. He is currently working as a technical principal RAMS at Mott MacDonald. Now I'll request Dr. Ajit Pandey to deliver his lecture. He is joined through WebEx.
Thank you, ma'am. Thank you.
Thank you, sir.
So I'm audible to everyone?
Yes, sir.
Okay, wonderful. So thank you once again, and thank you IEEE Reliability Society Hyderabad for giving this opportunity and organizing this kind of wonderful forum. I would like to thank Dr. Divedi, V. Shankarji, Arunji for a nice keynotes. I think it's very relevant topic for today for India. So I have been given to speak something on the RAMS standards.
Okay, so perhaps many people have mentioned that we are doing RAMS in MTech in RAMS course, which is a 2-year program. So in 20 minutes, we can summarize what is the benefits and how we can do it. Basically, in 20 minutes, I can't discuss about the RAMS standards and all these things. In fact, I'm delivering the lecture on RAMS for 3 days, EN 50126, only one. Anyway, so that is the good part is that we are here and we should understand where is the opportunity where we can explore more on this. So coming back to the railway context, okay, the railway is one of the most complex environment in any systems. If you talk about automotive or avionics, if you see railway, there are many systems from rolling stock, signaling, telecom, civil structure. If you broadly categorize the railways, basically it's 4 pillars. I can say it's 4 pillars. First is the infrastructure. Infrastructure means all the viaduct, track, stations, depot. Second pillar becomes the control, command and signaling. Control, command and signaling means maybe signaling systems, telecom systems, where some signaling controlling is done. Maybe SCADA also comes under that. Next is the energy. Energy means power supply, high voltage energy, low voltage energy, power supply, traction powers. And finally, fourth pillar becomes the rolling stock. If everything is ready, then rolling stock comes and run the train. So if you combine all the pillars, there are many departments. Okay, and in railway also, I am not a railway guy, but I have heard earlier there is member electrical, member mechanical, member civil, and okay. So the problem is every members if you work in isolated way. So see, so how to combine, how to proper handshaking all the members so that overall railway becomes safe and reliable. As you mentioned in railway, we are doing safety is of top importance. So European committee realized that definitely people are doing, there are good engineering practices and we are doing railway more than 100 years, even in India also. And we are running trains. So what we are going to do with the new thing RAMS management? What is the new here? So that is the European committee realized what is the best way where we can improve the operational performance of railway systems. Please mind operational performance. Why I'm pushing this word? If you see around the world, there are limited number of OEM. Maybe Thales is the for signaling, Alstom for rolling stock. Okay, maybe Excel counter processor. So even in India also, we are using the same Excel counter and same signaling system and same rolling stock. But the forum is here, all our Indian forums here. The forum is why our railway systems is not as better performing than European railways or Japanese railways. We are using the same Excel counter, we are using the same rolling stock and same signaling, but operational performance definitely, I don't hesitate here, operational performance is not as good as it should be compared to others. So it has been realized that yes, there is some gap is there. What is the gap? How we are going to implement all the RAMS concept from design. Somebody has some keynote speaker I heard that RAMS is the design properties. So from not only design, from requirement, from design, from installation, from operation. So every phase we have to do some systematic activities. So how to do all those things to make them proper? RAMS standard has been coined. The first RAMS standard, it is the EN 50126, okay, coined in 1999 by European Committee. EN 50126, first standard 1999. Okay, recently after 20 years, this standard has been revised, and the recent standard we are using EN 50126 2017. Okay. So the problem is the topic is given to RAMS standards. The RAMS standards, what I'm talking, it is the European standards. Similarly, some other countries, if you go to the Japan, they are following IEC standard. IEC, International Electrotechnical Commission. And they are also following the RAMS standard for IEC, that is the 62278. Similarly, if you go to America, they have their own standards, ARIMA in Australia. So RAMS standard is how the country specific RAMS standards even in future, I'm very sure in future with your support, we can develop our standard, RAMS standard for Indian railways or Indian metro systems. But since European has taken the lead, that's why EN 50126 is the harmonized and well adopted around the many countries. And they have given guidelines how to manage RAMS for the railway environment. Okay, so this is about the RAMS standard. The RAMS standard, what we mentioned, EN 50126, this is the first standard given by the European. Parallel to this, Japan has their own RAMS standard, America their own, and currently I was in Australia, they are using their RAMS standards. And I was in the other metro, Dubai and Middle East, they are following European standards. So it is, they are not enforcing, but if you can follow, if you can derive your own RAMS standard based upon EN 50126, you can develop it. Okay, because your environment is slightly different. So this is about the RAMS standard. So somebody has mentioned that we are following in India railway and signaling is the most important. And I heard some of the speaker mention RAMS is not only for the signaling, but it is applicable to other systems. Yes, it is correct. As per the European standard, the RAMS is applicable for all the systems, for rolling stock, signaling, telecom, every systems. But the applicability of these standards vary. Applicability maybe for signaling is more applicable because there is more active systems and more active safety is involved. But for the track work, it is less applicable. But in totality, it is applicable because if even a fastening fail in the track system, the rolling stock derail, so that is the whole safety will hampered. So that's why how to implement RAMS for signaling, how to implement RAMS for rolling stock, how to implement RAMS for the track, it is up to the client, and client will give some kind of target for MTVF. Just somebody mentioned MTVF, MTTR, and safety integrity level. There are many targets. Some target for the safety side and some for the reliability side. So these targets should be specified by the client. But now again, question becomes how to give targets. How to give target for the rolling stock? I'm saying rolling stock MTBF is 10,000 for doors, and but somebody has taken no, I will take 15,000. So this is the crux of the whole RAMS story here. I have been working in the many metro systems, okay, and this forum there are many seniors, many super seniors. They can ask some question here. None of the metro system in India, they are using any kind of RAMS allocation system through formal method. What they are doing, I was a RAMS consultant for the Hyderabad Metro. I have taken some data from the Delhi Metro, airport line. I have do some tweaking and try, okay, I think it's good because we have experts. They can say it is okay, I think it is similar. Similarly, in Bangalore Metro, they have taken some Kochi Metro. So all people are taking, I'm not saying they're wrong, but they're taking those data and try to make sure, I think it is similar to that system, why not to copy? But there is a formal method of RAMS allocations. Okay. So if you see the standards, EN 50126, the title is Specification and Demonstration of RAMS. That is only title. How to specify and how to demonstrate. So EN 50126, there are two parts. Part one, how to specify and how to demonstrate. It means how to specify RAMS target. They are saying you can use MTBF, you can use MTBSAF, you can use MTTR. There are many matrices given. So it is client responsibility and client consultant responsibility to select what is the metric which is appropriate for your system. Okay, and depending upon that, there is many standards which will give how to allocate target, and then he can write that contract document. In a contract document, they can specify their high level target. Maybe I want our punctuality of railway system 95%. So how to give RAMS target for rolling stock, how to give MTBF value of signaling track, so that if they all meet your punctuality target of rail level, it's clear. So this is the one thing. So RAMS standard gives guidelines how to specify and how to demonstrate. Because when you specify during design, you can demonstrate theoretically, and during trial run, during operational service, you have to demonstrate. Again, when people are from senior, none of the metro system in India till date are going to meet the RAMS target what has been given in the contract initially. So suppose on the paper they have see I will achieve the 99% signaling system. In Hyderabad also they have given, but during demonstration they fail at least for 6 months. Whatever the reason, it means there is some flaw there is some gap between allocation and demonstration and implementation. So if we systematically follow from beginning guidelines of EN 5026, definitely this kind of risk will be minimized. Okay, what we are going to design. Suppose you design for RAMS for the 99%. Similarly, you have to demonstrate during the field run and trial run. So this EN 5026 has a clear guideline how to specify your targets, how to design, how to verify, how to demonstrate, what documents will be written, how every stakeholder should involve. So this is the clear guideline given by the 50126 part 1. In part 2, they are more focused on the safety side, because safety is ultra important. So suppose some keynote speaker mentioned SIL. So what is the SIL level? How to design for safety? How ISA will come in the picture? So somebody has mentioned LRP also. I think Saxena Sarji has mentioned LRP. LRP is a one principle. LRP means as you design a system for safety, and certain safety you can't eliminate because of certain reason. So some safety, some hazard, if you can't eliminate, those you can LRP as low as reasonably practicable. So LRP is a UTA principle. Similarly, every country, because safety depends upon the socio-economic condition of the country. We are following most of the UTA principles. We are following LRP. Similarly, if you go to the France, they are following GAMAB, game theory. Okay. In Germany, they are following MEM, minimum endogenous principles, MEM. Okay. Australia, they are following SFARIP. So LRP is a one principle. So EN 50126 part 2, they are more focused on what is the safety implication of your systems, what the principles should follow, what the guidelines should follow. So more focus on the safety, and clients should adopt their safety policy or safety requirement from using help of 50126 part 2. Okay. And more important, this is a clear indication, this is clear guideline in EN 50126 that this standard is written for all stakeholders. It means, suppose you are client side, suppose you are Indian Railway. So this standard is for you. You means you will decide what is your target, and suppose you have given some contract to some Alstom, for example. So this standard is applicable to Alstom. What has been given, how to implement, and same standard is, suppose you have given contract to ISA, and ISA will come and do some audit. So they will also read the same standard. It means EN 50126 part 1 is a guideline, a Bible for all stakeholders in the railway, either client, contractor, subcontractor, supplier. Okay. So that is the way. If everybody follow the same Bible, same guideline, definitely there will be minimum discrepancy, and there will be minimum gap, and so that whole system will be collaboratively, progressively designed, operated, and maintained. So this is the first standard, and now I think this standard basically you can think again 50126 as a part of management part of the RAMS. Only management part of the management part of the RAMS is the EN 50126. Now, if you want to design your system, hardware or software, so EN 50126 will not tell you. It will see how to manage. But How to develop a software for RAMS? You have to follow EN 50128. And how to develop hardware? Suppose you are developing any hardware, maybe any switch, any signal system. So for that, EN 50129. So in the RAMS standard, in the RAMS industry, there are three standards: EN 50126, 128, 129. All three must be working together. So we are, as an industry, we are talking it groups of RAMS standards: EN 50126, 128, 129. It's a group of RAMS standards. So first, EN 50126 part 1 is the management standard, and EN 50126 EN 50128 and 129, it is the development standards. Okay. So without EN 50128, 129, we can't implement 50126. So this is the European group of standards. So these standards are keep on updating. So we have to keep trying. I have seen I got some document from some metros as a consultant. So still the people are using the same old standard. Whether standard has been revised. So recently, last year, EN 50128 has been revised. Software has been revised. That is the EN 50128 year 2020. And similarly, 3 years back, EN 50129 has been revised. EN 50129, is the latest version is the 2018. So nothing to remember. You go on the site and find the latest version of the EN standard, RAMS standard. You will find it, latest version. And what are the previous versions? So at the client side, we have to very careful that what standard we are using, and if we are not aware, so definitely maybe our counterpart, maybe they can give the wrong information and maybe not complete information. So these are the RAMS standards. So in summary, EN 50126 is the management aspect of the RAMS and applicable to all the systems, civil structure, mechanical structure, electrical structure, all the pillars. Okay. And one more pillar, final pillar, we can say ONM. ONM pillar is also independent pillar. I discussed 4 pillars: energy, infrastructure, rolling stock, and control command signaling. And 5th pillar is the ONM. Because if you design a metro system, a railway system, it will take maybe hardly 3 to 5 years. But it is designed for 25 years. How ongoing maintenance activities can be achieved? So that also must be followed the EN standards. Okay, because reliability comes on cost. So everything we have to demonstrate as a client. We have to demonstrate how much cost it will pay back. Suppose in Indian Railway, if we implement RAMS, for example, so how much it cost and what is the benefit? So somehow we can demonstrate the whole life cycle cost of the railway system, whole life cycle cost, ongoing maintenance. It can be minimized up to some extent if you properly implement RAMS in the railway system. As per my data, I mostly work on the metro system. A project cost to implement RAMS around 2 to 4%. So 2 to 4% of the total cost is for the RAMS. But it will pay back you around 17% in total cost, 17% profit as per my data. Okay, because cost of failure, ongoing maintenance, life cycle cost, replacement policy, there are many things, even apart from goodwill. So in simple words, what I can correlate in real time, future bigger risk of railway systems can be managed by paying a small premium into the RAMS. So it's like an insurance policy, term policy. Okay, we are paying a small amount to manage our future bigger risk. But in case of insurance policy, we are getting benefit only if something goes wrong. But in case of railway, in case of RAMS here, every day we are getting some benefit by optimizing the overall maintenance, life cycle cost. Okay, that is the crux of the RAMS management, and I'm very happy that this forum has given me the opportunity to discuss about the RAMS standard. And time is very small. Okay, I can speak maybe 1 day, 2 day continuous in the RAMS standard. But the crux is the RAMS is very important. It is equally applicable to all the systems, and it is applicable for all the stakeholders. Every stakeholder must realize, as the client will not think, I'm the client, I have a given contract, it's contracted duty to implement RAMS. No, it is completely wrong information. Okay, as per in standards, first duty is the client. Client should understand what is your target and how to allocate. Then next contractor will do it. With these words, I would like to stop. And if anybody has some doubt, I can clarify in 2 minutes. Otherwise, I think many speakers are there. And thank you so much. Thank you, everyone.
Thank you, sir. It was very informational. And if anybody has any question, then please they may ask.
Sir, any IS standards are for railway ramps? Anything being developed actually?
Please come again. Please come. Any?
Indian standards are there, sir. Indian standards for railway ramps. Anything is?
No, RDSO has developed some RAMS standards. I have seen. I got opportunity.
Okay.
But they have totally borrowed from the EN 50126. Still it to be developed. So I have seen the RDSO RAMS standard. The cover page is RDSO, everything's Indian, but internal content they simply take permission from the European to reuse. Maybe in future we are going to adopt to develop ourselves. As of now, no. We are following European standard EN 50126.
Okay, thank you, sir.
Sir, excuse me, I am Professor Shankar here.
Yes, sir, please.
Sir, do you have the RAMS standard in railways as devised by IEEE Standards Association, sir? There is one wing, IEEE Standards. We have not worked in that particular area, but I know IEEE Standards is there.
IEEE, there is no management standards. IEEE basically for signaling performance standard, IEEE 1747 something. So RAMS point of view, there is no IEEE RAMS standard. Okay, for management point of view, IEEE has developed the signaling standard for the signaling performance of design. Okay, maybe sub EMC. There are many standards, but only managing how, because there are many systems, how to manage, how to make a proper relation between all the systems. There is no IEEE standards. Okay, but I would like to mention one more thing. See, IEC 61508, one standard, IEC 61508, that is the mother standard for all the safety. That is the very good forum here to tell you. IEC 61508, that is the mother standard for all the electrical, electronics and programming electronics. So depending upon the industry need, maybe automotive, they want their automotive safety is different. So automotive has derived ISO 26262 from IC 61508. Similarly, railway has derived EN 50126, 128, 129 from IC. Similarly, aerospace has derived DO 178 from the IC. Similarly, nuclear power. So every industry specific RAMS standard, safety standard has been derived depending upon the industry nature from IC 61508. Okay. As per my knowledge, there is no RAMS management standard in the IEEE. Thank you.
Thank you, sir.
Any?
Good morning, Dr. Pandey. This is Lakshman. I am CST Construction, South Central Railway. I have interacted with you while you were working in Hyderabad Metro project, as well as in IIT Kharagpur, when I have attended this the 1 week course on RAMS.
Thank you.
My doubt is that now you have mentioned that the costing of implementation of RAMS is around 2 to 4%.
Yes.
Whereas if we implement in a metro project, the cost of the general consultant who is taking care of the execution of the entire project, it is around 3%. That is one thing.
Yes.
Now, in a metro system, let us say we are having 4 or 5 corridors. So in that case, if we do the RAMS demonstration for one corridor, will that be enough, or should we implement the RAMS demonstration for all the corridors? Why I'm asking is that if we can manage with implementing the RAMS demonstration in one corridor, we may reduce the cost of the RAM demonstration from what you have mentioned from 2 to 4%. It may be further brought down. What are your views on this?
So this is the very tricky question. So first of all, 2 to 4%, I have given a general things means suppose I have taken a contract for the supplying PhD in some metro project, PhD. Okay. So for me, I have taken maybe PhD, I have some idea data, maybe 60 crores I have taken. It means we have to design, manufacture everything. But as a PhD designer and implementer, I have to recruit some RAMS engineer as well. Because while delivering PhD to any metro system, RAMS engineers to verify how much RAMS and all these things. So 60 crores, 4% I have allocated for the RAMS. Because if you don't allocate RAMS budget to the every level, client level, consultant level, supplier level, so proper RAMS implementation will not possible. I have been in many metro systems. In India, it is 4, 5. In outside, around 10, 15 metro systems. So outside, it's okay. But India, what is happening? Even good companies, they have taken contract and they don't allocate RAMS budget. So what they are doing? Suddenly, clients say, no, without RAMS document, I will not get payment. So simply, they are doing some documentation. Because if documentation, you write RAM plan. I have seen many metro projects. So project is going to deliver, but they are writing RAM plan, RAM analysis. I think there's no use. So costing point of view, see, everything comes on cost. If you don't allocate budget, the subject cannot be implemented properly. So that is the costing point of view. So what to tell, 2 to 4%, it is applicable to all levels. Okay. Second thing, you told about the corridor wise. So metro project basically commissioned in different phases. So once client will write their contract, they will give all those things. Phase 1, phase 2, phase 3. So in the contract, target will be also given phase wise. Okay, phase 1, stage 1, what target, stage 2, what target, and you have to demonstrate stage wise. And after some time, in total also. So it is the progressive implementation of RAMS. You have to demonstrate you have to pass every subject and you have to pass in total as the exam. This is the concept. It's not single subject. Your total how much marks you got and every subject you have to pass. So I think I have more way to explain here, but forum is very less here, time is very less and many people are here. We can discuss again. Okay. Thank you so much.
Thank you.
Hello.
Yes.
I am Prasad here. Hello. Am I audible to you?
Yes, sir, very well. I can hear you.
Yeah. In continuation of the previous question, my question is, you said that 2 to 3% for the RAMs, and our payback will be about 17% of the total cost. How do you assess that one? That 17% you said, it is about nearly 7 to 8 times. But how do you assess that one?
Okay, so see, don't go exactly, never quote the Dr. Jesus 7 these things. So my point is, let me explain you, let me convince you. 2 to 4%, it is initial cost. Okay, we have designed. See, RAMS is a long-term system characteristics. It means system has been designed for around 20 to 25 years. Okay, so first few years, maybe 2 to 3 years, it will take break even. After every time, okay, every year, because your life cycle cost is 25 years. So how much life cycle cost you can save? So 17% on the total cost. It's not for the 1 year. So you invest only one time, 2 to 4% for the RAMS engineer, RAMS audits, ISI and all these things. Next, you can avoid many kind of, see, there are many factors why you have to implement RAMS. First of all, cost. I mentioned the 2 to 4% and around 15 to 17%. Around the whole life cycle, 20 to 25 years. Life cycle cost of maintenance, cost of life cycle, cost of many things are there. Cost of failure. Second, some goodwill also. Sometimes I have seen in Indian Railway also, some trains becomes unpunctual. There are tutors coming. All trains now 95% punctual. Indian Railway also. When I was very child, I have never seen Indian Railways populating something, my train is punctual and delayed. But now they have realized, but now customers are aware. Okay, if you are traveling in a train, okay, and you don't have water in your toilet, you make a tweet, immediately somebody will come and take it. Why it is this? These are RAMS. RAMS means this is the customer service. So now this kind of customer is aware. That's why. So RAMS is important for the goodwill also, cost, goodwill, and secondary. Some countries is regulatory requirement. If you don't implement RAMS in your design, okay, if you don't have ISO certificate in your product will be not get approved by anything. So there are many appealing justification why you need RAMS: cost, quality of service, and regulatory requirement. So cost, I'm asking you on the cost. Cost is for 25 years, and you can make it. I can demonstrate. I have some data. If time permits, I can discuss you how 15 to 70% cost will be paid back to the Indian Railway or any system if you implement 2 to 4% the RAMS.
Okay, thank you very much.
I think please forgive me. I think let us give the other speakers. I think it will become more. My apologies for the other one. Sorry for this.
Yes, thank you, Dr. Pandey. Actually, in fact, as you have mentioned, that you can demonstrate further reinforcement on this topic and subjects and queries. So I think we are in the second session. Our one paper presenter is not available. So if you can give some time on that.
Yes. Okay. I think this will be, so we can give some time on that. Okay.
Sure. Because a lot of queries are there. And I think you are right that we should give the time to the next presenter. Thank you.
Yes, please. Thank you so much.
One more question, sir.
Okay. Please. Please.
Sir, good morning, sir. I'm Venkat Raju, Senior DST, Secunderabad.
Okay.
Sir, implementation of RAMS is, if it is a closed environment, it can be achieved to 100%. Sir. If it is in an open environment, how we can implement and achieve the percentage of RAMS? Sir?
So again, basically, can you brief about the closed environment, open environment in your context? What you want to say, so that I can give right answer?
Sir, closed environment means suppose a signaling system, it is there in the electronic interlocking, which confined to the station one building, so that we can achieve it. The open environment means where my signal is at wayside place and points are in far locations. Which is open to environment and as well as to the in open atmosphere. So there, how we can achieve 100% RAMS in that, sir?
See, RAMS is not telling you to achieve 100%. RAMS is telling, first of all, what you allocate targets. Suppose you design maybe for the 96%, 98%. So 100% is what you decide, and then you no standard, even EN 5026, any standard, you will not see a single figure. RAMS standard will not give, doors should be designed for 95%, PHGs will be 93%, or MTBF of Excel counter will be this. No standard will tell you what is the value. Okay, it's my house. I have money. I want to make house like this way. If you decide, then he will tell you, okay, you have decided for the series 2. So for series 2, this is the method, this is the way, this is the approach, this is the demonstration, first of all. Regarding open and close, you are telling, so I should start the topic in different way. Basically, RAMS is a subset of system assurance. A subject called the system engineering and system assurance. So system assurance, there are many subjects: RAMS, EMI, EMC, interface, human factor, correct? So fire life, there are many systems. So system assurance means there is a package of system assurance. And in that package, RAMS is one of the most important package. RAMS, what talking? So what you're talking, how to implement system assurance for railway environment, there is a guidelines. Okay, so open environment, closed environment, everywhere we can implement system assurance, and that is the different topic. I think I will explain you. Yes. But it can be managed in open and closed both way. Okay, it can be managed. It is system assurance part.
Thank you, sir.
Thank you, sir. Next, we have Sri Somnath Palji, from IEEE Reliability Society, Hyderabad. He will be delivering lecture on quantified RAMS-based railway asset management. Over to Somnath Palji.
First of all, I'll just give a very brief introduction. I worked in Indian Railways for 37 years. And when I was inspector from that time, I was not knowing all these terms, but I prepared faulty analysis, failure mode analysis, even for ACSR and cable and all these things. So after retirement, I have devoted fully to safety and reliability. And on safety, I have represented India 8 times. My 8 papers have come up there in different versions. And in 2013, I was taken in as a core committee member of train accident investigation committee, even though in my life I never attended any accident. I was very lucky. मेरा section में कभी हुआ ही नहीं. But due to my logical ideas and these RAMS reliability based ideas I was given that time. Now for this IEEE Reliability Society in 2012, when I went to give a lecture on Indian railway reliability in US, I was asked by NASA, DOD, as well as universities that why Reliability Society chapter is not being opened in India. So I started asking everyone and whatever Saxena sir and Lakshman as well as Mr. Lakshman, अभी student मेरा था भूल जाइए, तो and Dr. Ajit Kumar, that course 2013 to 16 I have delivered lecture in that IIT Kharagpur course, and that course is designed by myself. And today I am very happy to tell the utilization of RailNet because people never accepted or recognized that RailNet was designed by myself and Mr. Pariyar. So forget that thing. And from last year, I have become member of Safety Culture Working Group in England because you know safety and reliability is almost not hard or not listened in India. And 2 days back, I have been invited to join this Rail Safety and Standard Board, RSSB, as affiliated member for reviewing safety standard in England. And even now, all very important train accidents information come to me. I am also a reviewer of IEEE conference papers. So now I will give a presentation here for quantification because engineers work with mathematics. तो आपका क्वेश्चन का आंसर हम दे देंगे. Okay. The first thing you see that myself I am author. I have been given a fellow of IRSC last year, and I am assisted by my younger daughter Poshali, whom I have handed over all my professional activities due to my health problem. Doctors told that I must leave all these technical thoughts and everything. I should only sign the papers and give the guidelines. And Poshali, and I have got very good my committee members like Madam Sharnabai, Dr. Shankar, Dr. Ravi Kumar, Dr. Anil Kumar, and several others. I have got fully help from IIT Kharagpur. It is open from me, Jadavpur University. And in Silchar, last year they have started thinking of one railway safety laboratory. And both myself and my daughter, we are taken in the advisory board for that. She is a software engineer, and she has also presented papers in International Rail Safety Conference on software testing of railway interlocking. We created world record in 2014 and 15, when in the same conference, father and daughter individual papers were submitted. Anyhow, I'll start. Yes. The first thing, reliability block diagram for relay system availability. Because what Dr. Pandey has told, we must know about each one and each one in series, because no passenger is interested to know that for what reason train is not working. Train is not working means railway is defunct. So for every department, and these diagrams have been taken from Sydney Metro, when in 2011 I went to Melbourne for giving lecture. They presented me the whole RAMS document. I got access to RAMS document of California, LRTC, Dubai Metro, and all this. So it is collected from there. And whatever I will show, all the mathematics and others are taken from other than Indian Railways, because Indian Railways, I never found any data like that. And I was also, sir may know, that people have started telling me that you are chamcha of Dr. Rajaram Bodji for that ACD and all these things. Because you know that China has got developed ACD and all this. And in 2013 in Vancouver, they presented their paper, and when I started asking question, the speaker just took out one paper from his pocket and he told, "Are you Somnath Pal?" I told, "Yes." "Well, we have been instructed then not to tell anything to you." But I get full support from Japan, US, and others. So after that, this is the first structure. Now you see. Next. This is the conventional asset management. The first thing, conventional system, you don't do any quantification, no mathematics, no data, because actually, I'm very sorry to say that almost nil data is available. Indian Railway, and one final thing in my view is that accident investigation reports which were available in EDSET, it was written that it cannot be diverted outside the library. Even students cannot take to the hostel and study. In other countries, no accident report comes like that. Once an accident report, preliminary report is made, it is sent to universities, research centers. They also come to the points, and after 3, 4, 5 years, they come on the final. I would request SND people, you read this very recently, Cranberry accident. Accident हुआ नहीं. Level crossing gate में आके train stop करने के बजाय gate खुला हुआ था, चला गया. Afterwards it was found, it was ETCS2. So there was duplicate computer, but one computer stopped and there was not automatic switch over to the software in a second. And that was certified. So I immediately raised question, how ISA has looked over this point. And my point is that I was very lucky in EDSET that I was allowed by Dr. Verma, then S.C. Gupta, Pariyar, and P.S. Venkataraman sir, that I retired in 2007. Up to that time, every equipment in EDSET, whether signaling and telecom, I could teach in component level. Every component, if it fails, what will happen? And I was just mentioning about my daughter. For her, I have written a book on signaling to teach how to teach engineers. Everything is told with state transition diagrams because software करने के लिए वो सब जरूरत होगा. Then every relay circuit, LR relay बोलिए, UCR बोलिए, every relay circuit has been taken, and उसमें mathematically what is the rate of safe failure, what is the rate of unsafe failure, what is the timing diagram, everything. So that way he has taught, and as I know already, EDSET is preparing courses for engineering colleges. Parallelly, IEEE Anantapur has also asked me, IEEE. So I prepared myself and Shankar sir, we have prepared courses on railway signaling. I have taken some classes in IEEE. I taught in my own way with state transition diagram and mathematics and all this Markov modeling and everything. We have also brought one course in human factor analysis, very important. I will show one slide will be there. You will have about 48 different causes of human failure. So every manager should take care of all those things. So another one is safety culture, because there is no safety culture in our life. And I'm very lucky that I'm vice president of one Bengali association in Manikonda side. And children from 9 to 15 years, they have presented a brilliant safety culture presentation, 61 slides, and that has been highly appreciated in Massachusetts University, Cranfield University, and other places. I would share with sir that slides you go through, and I have already told Arnikar madam, will be assisted by my daughter, to have safety and reliability culture for the domestic women. there is another concept, women in engineering. There are a lot of women engineers in every department in Indian Railways, but there is no women in engineering association group. कुछ दिन पहले मैं I don't know her, I have never seen Priya Agarwal. I got some paper, it was very interesting. I would request her to give lecture in IEEE. I want that people should get associated with all these things. So this conventional type, even I think this fact and risk-based compliance is not there. Because people at the ground level are very much afraid to tell what is the actual fault. They're always, because there is no openness. So that will never solve the problem. You must know. And sir already told me that he is inviting ground level people to tell their problems, because they only know what is the problems, actual problems. Then implementation of the competent staff, proper training. क्या training होना चाहिए? Now you see that maintainers are going to maintain the field, but they don't have any, what is called, template. What is to be checked? Our people are not knowing that, say, I take the reading of the battery, I fill up the columns and everything, but why did I take the measurement? It is not only for checking today's view. I am checking the trend. What was the value last 2 times back? How it is going to fail? All these things comes under RAMS. Then asset procurement, how you are going to procure. I'll show all these things. And transparency, which is very important. People should not be afraid to discuss. You discuss. Next. So why QRAMs, quantified RAMs with mathematics? Everything what I will tell will be established with mathematics. So life cycle cost, in the tender, I get 3 or 4 offers. We are always thinking of the procurement cost. We are never thinking, say it will work for 10 years. What will be my cost over 10 years? There are several types of cost. All these we must know. Then pick the best offer. Then choose best maintenance policy. How they will maintain. Whether with AMC. Now in AMC, the cost they are asking, is it justified? Only with mathematics you can find if you have got the data of the failures. Then they have told that I will give you 99% reliability. Not now. I want that my SSI will work for, say, 12 years. So at the 12th year, what will be my reliability? And people should understand that reliability is function of time. So every year reliability value is reducing. So RDSO must insist what will be the reliability up 12th year before releasing, and back calculate. You will find that reliability at the first year will be higher. Now, are you going to pay the cost? Because now I am hearing that even 4% for RAMS cost seems to be very high. No, it is not a cost. It is essential and must mandatory. Then you see, prioritize various renewal plans. How you are going to renew? After how far year? Maintenance job करेंगे, whether corrective maintenance or reactive maintenance, failure होने के बाद जाएंगे, or preventive maintenance. Now, if you have preventive maintenance also, आपको system down करके करना पड़ता है, availability goes down. So you must have predictive with nowadays IoT based predictive maintenance. Take the case of point machine. I am thinking of meeting MK Rao. He is now point machine are being manufactured in Metuguda. So how to diagnose faults in point machine? I've seen in Melbourne some 20 aspects they are checking. So Jaipur University started all these things, but अभी 4-5 साल से बंद है. I am associated with them. I have given them some idea. A very small thing, very fundamental thing. We can check the sound of the motor. Because if there is some obstruction or greasiness or anything, sound will change. You use Kalman filter, monitor that sound. You can immediately find that it is going to get some problem. Like that. You use your brains. And I am always telling, because some few days back I had to have interaction with Andhra Pradesh and Telangana engineering college students. I told India do not need qualified engineers. We want learned engineers who are really engineers. So that engineering concept should come, and a very good thing that a lot of students want. I should be mentor for all the engineering colleges here. So definitely, my main idea is that why China will come that fast and why we are not there. You don't know, in international seminar, Chinese are telling that before we opened our training center in Beijing, there was a training center in Hyderabad which is closed now. Can you imagine what is the audacious comments? I had to face all these things. And people are laughing against me because I am the only representative who had to spend money from own pocket. Because neither railway nor any company nor anyone bothered. I spent 16 lakhs from my pension for going to foreign countries. Now I told enough is enough. Aur nahi kar sakte. So you will have to come close, get open, talk with these experts. So these are the benefits. Next. What are the inputs? That is risk. What are the risk influencing factor? Which can fail more and fail in the answer side. So probability of failure in dangerous mode, PFD is very, very important. Then vulnerability, how it can be vulnerable, because abhi Pandey sir bataya, your axle counter, your track circuit, they are in the open space. So what will be the effect of the weather, environment, EMC? You take one very simple thing. I do not know how many of you are thinking that all our electronic equipments are having power supply at the lowest rack. And these powers are always evaporating warm weather. What will be the effect of this warm heat to the next rack, PCBs and all these things? Now when we are having, say, duplication or triplication, 2 out of 3, 2 out of 2, most of the cases we find that both the processor cards are side by side. If there is any common mode failure in the motherboard, everyone will be affected. The safe lock has a very good idea that it is two processors are working, but they are not working together. While one is taking input, other is calculating. Why? Because you have done everything, software diversity, alag software liya, alag hardware liya, but input is common. So input also should not create any common mode failure. You must have diversity in the design. Why in the output circuit you are having a transistor operating a relay in series? Why? Because transistor will not have any mechanical problem. Relay will not have any electronic problem. So both cannot fail in the unsafe condition in the same situation. You'll have to think that. Why we are taking both pickup contact and drop contact? Because it is safety oriented circuit. And not only that, few days back, गवर्नमेंट सर मेरे को पूछा था वो पिकअप ड्रॉप जब करते हैं तब उसमें रिले में थोड़ा बाउंसिंग भी हो सकता है. प्रोसेसर इज वेरी फास्ट. आई डोंट से इट इज वेरी सिंपल. उसमें आप फ्लिप फ्लॉप लगा दीजिए तो फ्लिप फ्लॉप विल नॉट वर्क लाइक दैट. ऐसा फ्लिप फ्लॉप परमानेंट स्टैक में रहेगा. One funny question I found, funny nahi, question was very good, but never asked by any of my student. While I was teaching about bullies or rail magnet in ETCS, my daughter asked, Daddy, train is going at a high speed at 120 kilometers, and your ballast is say hardly 2 feet or 3 feet. How it is calculating that pulse? I told you, use your brain. It is very simple. At the input circuit of the train equipment, there is a pulse stretcher circuit. Very simple. So that's why you must know what are the tasks you want to do and what are the resources. Ab matching kijiye. I'm always telling signaling circuit is very, very easy, much, much easier than telecom. Because in telecom you have got binding of time. Itna time mein aisa karna padega. Another thing I'll tell, I think Lakshman may remember, young people may not remember. In OK exchange, power supply on condition में आप input output card निकल सकते हैं. But always remember, when you are inserting the card or taking out the card, what will be the transient. Many of our people do not know that हम जब 230 volt का switch on करता है, switch generates 3000 volt. So उसमें क्या किया था? पावर पिन थोड़ा लंबा किया था, क्यों? पावर पिन पहले घुसने से जो वोल्टेज आता है, that voltage will charge the capacitor and capacitor output will go to the ICs. So ये fundamental अगर हमको मालूम नहीं होगा, how I can tell the designer? So remember these type of things. So output is sustainable infrastructure through evidence-based decision making. Everything should be documented. Standard documentation, जो Pandey sir बोला, it is very much needed. He requested me make a standard on RAMS for Indian Railways and metros. I told, who is going to listen? When I was working under Buddhadev Datta Chaudhary and worked for RAMS in Hyderabad Metro, there was CST, I will not tell his name, very famous. He told that I know that you are very much irritating. You are telling people this point, that point, that point. We are not going to do it. I immediately told, sir, I am resigning from this work. I will not do anything. So if that approach is there, I raised a single question. I don't know how many of you have thought. I told that when you are going to open a railway station for metro, did you do any survey that nearest wine shop is how far? Because in the evening, one single lady in the platform, and you know about Hyderabad area wine shop ka queue kaisa rehta hai. If someone, drunk person comes to the platform and irritates this lady, who is responsible? They told, फाड़ के फेंक दिया मेरे सामने वो पेपर. बोले ऐसा मत सोचिए. मैं बोला सर यूरोप में ये मैंडेटरी है. I work with them, I know it. You don't manage, but हमारा सामने फाड़ देना out of courtesy. So this is the approach. I want to break that approach. So quantification using mathematical and statistical methods. Here you require universities. Next, we need not break our head for everything. There are hundreds of research scholars. They will do research. What are the components? You see, rigid and unanimous requirement specification. Now, I think 90% of the engineering college students do not know how to write one page in correct English. So what requirement specification is made by headquarters, there may be some ambiguous language. So that company people will take that chance. Ab court mein jaake kuch nahi kar sakte. So they will have to learn how to prepare the requirement analysis. Then reliability and maintainability allocation. It is very simple equations are there. I will show the example. Then procurement policy with optimum life cycle cost. Then trained staff is very, very important. And proper checklist, manuals, drawings, tools, and measuring instruments. I find it is very much not available. Then best maintenance practice with adequate spare parts, whether spare parts will be centralized or distributed. So if it is distributed, you will have more number of spare parts. If it is centralized, you will have to logistic, how the person will reach that place. Now in many places, suppose section engineer, he is having the key of the stores. Lunch में गया, उस time failure हुआ. No one is having the access to the key. वो आके की देगा, सामान लेगा, और सामान लेके 15 किलोमीटर दूर में जाके करेगा. Who is going to accept this empty tier? Then evaluating suppliers, maintenance, cost control, as I already have told. Then best location of stores, I have already told, and everything must be documented. Next. How, what requirement specification? You are going to take on SSI. What are the points to be checked? System requirement, operation requirement, functional requirement, procedural requirement, diagnostic, power supply, then physical construction, as I told, different rack mein rakhna padega. Maintenance requirement, performance requirement, environmental, lifetime sustainability, modification if required, and software. I have guided some university students. आपको कुछ क्वेश्चन किया जाता है फॉर प्रिपेयरिंग सिलेक्शन टेबल एनालिसिस. You give that question yes or no, or how many lines, where the loop is there. You just click, you give enter, it gives the yard diagram, it gives the selection table. And I was told that I will be taken up for doing this exercise. Written मैंने को order दिया था, next time you will be punished. And after my retirement, I have been told, sir को मालूम है, yes sir. Yes, I'll explain it. Because I'm clearing the points. This is the very important thing. And because Shintu is not coming, I can take 10 minutes more, no problem. So you will have to follow this. Documentation. Next. Reliability allocation. There is a formula. Say you are going to have a new yard. You find how many points, how many axle counters, what are the track circuits, and then what is your life, and find the failure rate. And you fill up, you will find, say, axle counter kitna hai, track circuit kitna hai, and that after how many days, how many years, you must specify. Next, choosing better procurement. I have showed only two. Here you will see that system B shows less failure rate and MTTR. But ultimate cost, if you do the life cycle cost mathematics, you will find that system A is much better. So you'll have to give in mathematics. Because when I was in EDSET, just before retirement, twice or thrice I was in tender committee. I started talking with the stores department and accounts department. I fought with them. ये mathematics दिखा के मैं सामान ले लिया. Next. Periodical inspection is also very important. How many days? We are always normally sending, after 7 days, we are sending maintainer to check. Why 7 days? Why not 9 days? Why not 5 days? So mathematically we will find if it is done 168 hours, that is 7 days, you will get maximum availability. Mathematics. Next. Reduction of reliability over time. Next, click. You see that after every year, your rates are coming down. That is, failure rates are increasing, reliability is coming down. I have already explained. Next. What is the reliability design process? So you see that specify the reliability goals and concept, then determine system effectiveness as well as life cycle cost. ये दोनों उधर हो गया. And the right side you allocate reliability for the components. Then you implement design, how it is to be designed, and then failure rate calculation, whether goal is achieved. If no, do everything again. If yes, then systems safety finalize करके whether safety goal is right. If yes, design is complete. So that way you'll have to think of the design. Next, procurement. What points you are going to ask? MTBF and MTTR, availability, design life, how many years? Spare supply, cost. Cost depends on operating cost, then acquisition cost, then labor cost, as well as you will have to pay back some money to someone, NET. All these will go to life cycle cost, and you will also have sample size. How many samples you are going to take? Check with 99% confidence. So RDS must tell that I will go for 99 or 98 or 97. 1% increase means your number of samples will be increasing, cost will be increasing. And acceptance policy. If it is a new thing, type approval. If it is a foreign thing, cross acceptance. You must have guidelines. Next. Maintainability design. Specify maintenance goals. What will be your MTTR, what will be your MTBF and all this. Then determine system effectiveness. वहाँ खत्म हो जाता है. Right side, allocate maintainability allocation also for each component, each PCB like that. Then implement design methods. Then whether redundancy 2 out of 2, 2 out of 3, double 2 out of 3, warm standby, hot standby, all these things. And perform maintenance analysis and then assess. If it is done, final. Next. QRAM's components for maintenance. At the left side, you see empty tier. It depends on preparation time, verification time, fault localization, parts replacement, logistic, final testing, overall administrative time is also needed. Then there are other points. I think some of these are already being followed, but it must be documented and audited. You'll get all these presentations at a later time you can go. Next, time elements of a repair. I have showed it in a more detailed vision. Here system logistic time and system testing time is also needed. Because control fail हो गया, right होने के बाद controller immediately write नहीं करेगा. He'll take 15 minutes to 20 minutes to verify. That 20 minutes also you must count in empty tier. Next, comparing various redundancy configurations. Next, click. So I have done the same design of the cards. If I have 1001 with diagnostic, 1002 without or with diagnostic, 2002 with or without diagnostic, 2003. After comparison, you will find next, click, 1002D is the best, followed by 2003. Because 2003 will give you availability, but because of more components, it will reduce your reliability. Remember. Next. Points and crossing. I've just made one fault tree. I wanted this thing. I've asked several S&T persons, do you have this type of thing? Can you give me, say, last 1 year, कौन सा part में कितना failure हुआ? No one is having. I'll request sir कि ये आप ऐसा चालू कीजिए. It is a very, very important thing. Next, spare and repair cost. You must have this. And next, so you must think when you are going to replace, when you are going to repair. The cost comparison करके availability of the spare parts, you'll have to take decision. Next. Now, company has given you that this is my maintenance for the next 10 years. I have given some questions, say, the tests and how much failures are there, what are the time. And after that, I find that 95% confident that 86.81 repairs were done in less than 5 hours. But we wanted target was 90%. So contractor is not meeting my requirement. RAMS target meet nahi kar rahe. You'll have to catch. Give the payment connected to these. Next. Achievement of maintenance goal, again, like that. Then compliance to specification. You have specified that itna failure आना चाहिए, but we are finding that feasibility कितना है. तो point 9. So are you happy? You see, next click कीजिए. Specification is not being met. Why? You have asked at the top what should be the maximum specification. That is minimum time requirement. इतना तो होना चाहिए केस में. Go to next. These are the documented. What documents are needed? All very important. At present, almost nothing is available. Mathematically, nothing is available. No one is doing research. And the other thing I will, sir, ask, many times I am being asked from EDSET, from railways, why people are not publishing international papers. Encourage that thing. तो क्योंकि आपसे मैं बहुत बात करता हूँ, I have got कि आप रिटायर करने का पहले उसके बाद तो शायद एक कल्चर भी बंद हो जाएगा. I am totally free. जो मेरे मन में आता है मैं बोल देता हूँ. So this is the trend I am finding. It must be started. Next. And what are the contributive factors? You will find more than 40 factors are there. Human क्या fail कर सकते, किस लिए कर सकते. In Japanese railway, if 1 minute Shinkansen train late होने से, bullet train late होने से, the crew goes to hospital for 1 month and उसको ट्रीटमेंट होता है, साइकोलॉजिकल ट्रीटमेंट होता है. And they asked me, क्या कर सकता है? I told already one of my friend's daughter in US, she has opened one new company to deal with trauma, how to bring people out of trauma who are working in safety culture. I have joined there. All I am doing without any payment or everything is social service. So this is a very important one, and this was presented in Germany 2014, Berlin. Next steps and future work. So everyone talks with IoT, artificial intelligence, blockchain and all these things. Here I will tell that I don't know how many of you know S.N. Gupta, our old faculty member. He is chair of several forums in telecommunication. One is root server installation in India by 2030, internet server. Second is through Wi-Fi 6. Every villager will be given Wi-Fi connection. This will be done by DOT and BSNL, CDOT and BSNL. And third is blockchain for railways, and IEEE Reliability Society is associated, and I am invited guest for all these forums. सर बोल रहे आप खाली सिग्नल का पीछे कर रहे हैं और सेफ्टी का कर रहे हैं, टेलीकॉम के लिए तो कुछ कीजिए. I told yes sir. Traffic analysis, I don't know whether in ERISET PT was supposed to come. I don't know who is PT, ERISET. So traffic analysis, is it being taught? I don't know. कॉल काट हो जाता है, क्यों काट हो जाता है? देयर इज नो ट्रैफिक एनालिसिस. आपको बीएससी का क्या कंडीशन होना चाहिए, आपको बीटीएस का क्या पावर होना चाहिए, व्हाट शुड बैंडविड्थ, नथिंग इज बीइंग कैलकुलेटेड. तो सर बोला कि आई मस्ट कैलकुलेट ऑल दीज थिंग्स. सो आई थिंक दैट इज ओवर. नेक्स्ट. एंड बिकॉज स्लाइड्स आर गिवन इन इंटरनेशनल सेमिनार, आई हैव रिटन इन lot of things, and off late I'll tell. Already Saxena sir se baat ho gaya, he has recommended, and IEEE chairman, whole world chairman has become one lady, Bengali from Bangladesh, Dr. Saifur Rahman, next year. And for women in engineering, another lady, Bengali, Dr. Celia Shahnaz, she has become member. And I have been, both myself and Paushali were invited because incidentally our ancestral house is in Dhaka. So they told that being IEEE Reliability Society, you must help. So we are ready to help. And कल रात को सक्सेना सर से मेरा बात हुआ. I think Indian Railway में lot of experts are there. हमारा इतना उन लोग को जरूरत शायद होगा भी नहीं. तो we have thought of that Asia, Latin America and African countries, we are ready to help without any cost. This is our social service. Okay, thank you. And just one point I will tell, in the month of November, Dr. Ranikar and Dr. Muthukumar in DRDO, they are having 3-day conference. 1 day only for safety, 1 day for quality, 1 day for reliability. And I told that international speaker को हम बताएंगे आने lecture देने के लिए, because when our section was inaugurated in 23rd October, I invited Massachusetts University professor MIT. Could you please give a presentation? Immediately within 2 hours he told, आप request किया हम नहीं आएगा, how do you expect? But I have got only one question, request that your daughter must be moderator for my paper. So that is a great honor for her also. तो हम लोग किए हैं. And कुछ ही दिन पहले, last month I think, safety culture, England का safety culture group का chairman, he has given lecture. I had only 3 audience except myself, Anikar Madam, Shankar sir. This is the situation. We cut a very sorry figure. He told Somnath, don't worry. If one person is there in America and Canada, professor takes class. At least 3 आदमी तो आए हैं. So that thing, you must come up. And sir को तो मैं बोला ही है, IEEE is always ready to just interact. क्या चाहिए आप बोलिए, we are ready. Yes, Ajit Kumar sir, बोलिए. Okay, I thought that. Okay, that's. Thank for patient hearing, and I hope that you will try to do something on this line. And I'm always ready to help. Thank you, sir.
Thank you, Sri Somnath Palji. It was very insightful. And if anybody has any question, then they may ask, please.
Or you can ask in my email. I'm always open.
I want to ask a simple question.
Boli, sir.
And Mr. Paul, you studied components level in research about the failure aspects and all that. Now, if it's in Hyderabad Metro, we have used the Oslo spine machine. The MTBF for Oslo spine machine, which has been used in Hyderabad Metro, is 5 years. I want all our ascent engineers to understand the MTBF is 5 years for Oslo spine machine. So once it fails, next failure should not occur till 5 years. When compared to that, the point machine, our IRS point machine, I don't think the MTBF is 5 years. So I want to ask from you, how do you think that we can improve the MTBF in IRS point machine?
Use better components, take the stress. That's why HALT and HUS, I think some of you may know, highly accelerated life test, highly accelerated stress testing. वो सब करके just for electronic components, you have got MIL standard 217F. Madam is expert on that, I think. And MIL standard 338B. All these were available in ERISET. I think it was never touched. But for mechanical things also, there are ARINC standards. I'm very much fond of standards. I read standards and I review some of the international standards also. So, you can ask the company, demonstrate, because वो जब equipment आपको दिया है, they are first given to acceptance testing to RDSO. Then definitely RDSO people must have gone through this calculation. They wanted demonstration, but here I will tell कि मेरे पास ऐसा भी खबर है कि in some places SSI was accepted by one signing authority was TCI. I know him personally. He has got no knowledge in signaling. I asked, how dare you sign that? तुम कैसे देखा उसका डॉक्यूमेंट ठीक है कि नहीं? तो बोला नहीं सर वो तो उन लोग साइन किया. If that is the idea, what you can do? So what I am telling, you choose that these persons are future people in RDSO. So they must be given special training. MIL standard 217F SICO. And another thing, MIL standard 217F is for exponential failure. But all failures are not exponential. So you must know the Reliability Society will give all these ideas. We'll interact and वो company से पूछिए जो MTBF वगैरह claim किया उसका document क्या है. I'm again telling for this UFSBI by UFFIL that was idea of Dr. Odun Saxena. Odun Saxena sir. And after it was prepared, I was given the job of checking each and every line of the document. And I have certified unofficially, because officially it is not needed in Indian Railway, but SC Gupta gave me this power. You signed. जब signaling equipment आया है, Microsoft, I asked some question. Microsoft का chief जो engineer है, personally मेरे से meet करने को आया था, and they wanted to install one microlog equipment in my quarters. बोले सर इंस्टीट्यूट में नहीं होगा, आप अपना क्वार्टर में हम लोग बैठे रहते. I told, do you want I should go to prison? No, I don't want all these things. I'll give idea. At present, some of the Middle East countries and others, they're developing SSI. They're taking my help. I told, but don't reveal that I'm helping you. My name should not come anywhere. I'm ready. And we work in many encrypted way. Okay, fine. Thank you.
Thank you, sir. Now we will break for tea and we'll join back at 12:15.
Just a small comment.
Yes, sir. Yes, sir.
This
Yes,
question
sir.
of TBF of point machine, what he has raised, that's a very important question. The problem is we have not maintained data of any kind on that. The way you have maintained data of MTBF figures for electronic systems, if you look at the MTBF of our IRS point machine, it is not less than 5 years. You look at any point machine, it does not fail before 7 years. I am talking of Bombay division where we are having a strategy of replacement of point machine in 7 years. So what I will request is that if you just have the data on this subject of point machine, you will come to know that we are not very far off from the MTGA for 5 years. Second thing is the has been controlled and all of us know reliability. Most important factor is environment. The environment is not over, the failure rate goes high. And therefore, the environment of metro and environment of on open line railways cannot be compared. And therefore, that is one reason that the reliability of the MTBA figures, if you really work out of point machines, if you just take the data of the last 1 year. Last 1 year, we had something like 600 point machines. Just work out for a single year data. Thank you.
Thank you.
Thank you, sir.
Morning, sir. Sir, it's not a question, sir. This is Dinesh, Professor Telecom from Research. Sir, it was good to listen to you, especially the reliability standards and the calculations which you have been doing for the signaling instructions and all. Sir, the request is it will be good if you some other lecture sometime later. Lecture on how these reliability standards, everything need to be applied on a when you go ahead designing with a telecom network. If that also can be covered sometime later.
Yes,
given
definitely.
it's a kind of open invitation to you.
Yes. So we'll break for tea and come back at 12:15. Thank you.
बोलिए
सर गुड मॉर्निंग, गुड आफ्टरनून सर। हाँ, हम रेडी हैं सर। और मैं तो ये अपने इस पे हूँ, पीपीटी दूंगा। यदि इनकेस कोई इशू होता है तो मैंने आपको मेल में भी दे के रखा है वो पीडीएफ, है ना सर? मैं हूँ वैसे।
It's 12:15, huh? 3 minutes to go.
Actually, in our subsystems, we do the derating analysis, sir, at the design.
नहीं, वो है।
You said due to constraint of time.
Yes, because I have taken only some slides.
And also, sir, you are saying reduction in reliability over time. Okay.
E to the power minus lambda into T.
Yes, sir. Yes,
So
sir.
T is important.
Yeah, but actually, in our case, mission life is 5 years.
Last year में क्या reliability होगा? If you do the back calculation, you will find the initial acceptance का time में क्या reliability होना चाहिए. That is very important. Yes.
And also, sir, in the first talk, na, Dr. Pandey ji, he was telling EN 50126, 128 and 129. I want to know whether any EN standard is there for testing. Any exclusive standard, EN standard for testing if it is there. Otherwise, how European countries are testing their subsystems for their railway? Is there anything?
I'll give you guidelines. हाँ, उसमें भी clear नहीं है. Just you will have to do this as a. Yes, yes.
Okay, sir. I am yet to go through it. I will go through it. So, because just the 3 numbers were there, so out of academic interest, I asked. Okay. Something. Yeah.
Welcome back. Next, we have Shri Rajesh Patel, Chief RAMS Engineer, Mumbai Metro Line 3. He's an IRSSC officer of 1990 batch who worked for about 16 years in Indian Railways in projects management and railway operation and maintenance, including 5 years in Konkan Railway and about 12 years in private sector in railway domain. He has more than 2,000 man-days experience in imparting training in railway RAM and safety system training, including EN Senelec standards for railway application. He is certified Six Sigma Belt, Internal Quality Auditor ISO 9001, a professional doctorate in management from ISMS. So I would, the topic he will be delivering lecture on system safety case requirements and development. Over to Shri Rajesh Patel, sir.
Thank you. I am audible?
Yes, sir.
Yeah, okay. Thank you.
Yes, sir, you are audible.
Yeah, thank you. Very good afternoon to Dr. V. Shankar sir, Devedi sir, Kalsi sir, and Arun Saxena sir. It is a pleasure to have with our railway fellow, and some of them are really guiding fellow with my career. Thanks, Mr. Somnath Pal sir, for giving this opportunity through IEEE Hyderabad to present a safety case requirement and application. I will share my presentation. Just I am given permission to share. Just
Done? No, I think it's not an issue.
Sir, you can share.
Yeah.
There is no problem from this side.
Yeah.
Easy outdoor unit key.
Yeah. Are you able to see the first slide?
Your presentation is visible, sir.
Yeah, thank you. We will start this very important one of the document, which is the key document in whole RAMS and safety.
Excuse me, sir.
Yeah.
Sir, can you please
Yeah.
do it in presentation mode? Thank you, sir.
Okay. So this is the key document, a safety case document. What Dr. Ajit rightly said, it is all started with IEC 6150508, where different European and standard has come up sector-wise. Like EN 50126 has come for railway, and different things come from process and our nuclear power also. So this is the document which everybody should see, and this is the key document. Before starting this one, how this standard has come, because there is so much confusion and requirement of this one. It is all in some mid 1990 when European whole union was in a shamble, European sector. So they have come up with the how this interoperability can come for the rescue of economy. And when they go for economy, they find there is a issue of interoperability. And when they say come interoperability, then they cannot define what are the system requirements, what is the customer requirement. So customer requirement become a reliability and safety. So they come with this one because say when we are defining any rule, etc., we have to see that technology should not be smothered. It should be given enough space to develop its own, give us definite solutions. So they have started with EN 50126, and there was these are the big company, Alstom, Siemens at that time, Bombard at that time. They have come up and contributed in the whole sector. Government was also a stakeholder. So different industry fellow has joined, and they have come up with this one. Now about 34 countries are part of this EN European company. Because India is also looking at, because whether we have to see IEC or 61508 or EN 50126. So we are in most of our contract we copy it as 61508 and we see. So whole idea of safety case is the demonstration of your claims. So my presentation is the objective is the railway system, what are the subsystem, what is the system, what is the project. Because the safety case basically it is a basic requirement for cell confirmation. So there are many subsystem and then build up system and then we go for project. How we go for this one, I will see. As far as safety case is concerned, this is a very well structured document. There are very defined sections are there, and we have to follow that one. It is not a safety report sort of, it is a safety case by name itself, and it is defined in the EN 50126. Earlier it was in EN 50129. Then we see types of safety case, because there is so much people have submitted safety case, but what safety case it is, that we'll see that one. Then requirement of safety case and how it is connected with life cycle. So end of the section we'll be able to understand system, subsystem and project of railway sector, because we are defining EN 5012 for railway only, and then section of railway, life cycle of product, and how, because ultimately whatever product you are giving, they have a life cycle. So how safety case in phase wise we are taking the proof of compliance. Then type of safety case, this is a design, we call it general product and application safety case, and then specific application safety case. Then requirement of safety case for product and project. So how you will compare. So I will start with this one, because railway is a very complex environment. And here you see the reliability and safety will take for RAMS. It is for EN 50126 taken. Here you see there is a three sectors. You say system condition, operation condition, and maintenance condition. So every pillar has their own uniqueness. And what safety case is both for risk mitigation, how you will make it, like sir has said, this LR as low as reasonably practical. Ultimately it is the money, it is the economy which matter. So how our engineering should meet the requirement, it should not be go to uneconomic solution. So solution should be within the economic prudence. So in this way, all safety case, when we go say system conditions, we go for the technical things, there are internal distance. So in safety case, basically we go internal differences. I will later also take it how external, because now this cyber security is a very big issue in the whole sector is finding. So how those security, because thing is not safe if it is not secure. So how that point will take, I will in the last we will discuss that one also, how cyber security can be part of this one. So when we go for safety case, we will first of all system failure, systematic failure and random failure. Here some of the things, systematic failure, what are the things, like in our design specification, tender contract, whatever give, whatever we write from the system requirement specification to functional requirement specification, testability, their test procedure, etc. If there is some vulnerabilities there, weakness are there, how it will go to effect, how it should be controlled. And there are random failure, because this is the very peculiar sort of things are there. Environment stress are there. We are just copy pasting for European specification, but their condition, their environment condition is quite different than in India, or there are many failure which occur, which are not we have seen in the proper perspective. So like you know, all this is metro we have taken like metro, where are the subsystems are. The metro, if we take a whole system, then subsystem with a rolling stock, civil and track structure. EN 50126 are electrical, electronics, and programming electronics. So normally for pneumatic and say mechanical thing will not cover, but we take different perspective how it can be useful. Like in rolling stock, when we go for braking system, so there is so much pneumatic is about. So concept of electrical, electric programming, electronic safety identification we apply in brake also. Then traction subsystem. This is a very key sector, because this will define in metro. You say this is defined in metro. What is the power supply, energy sector, energy system is there. Here you will also see how SCADA is very important, which is also sea level. The signaling template, of course, this is a solid state interlock, AFTC, etc. These are systems. I have highlighted some of the subsystem of the main system just to show these are the seal. So they have their safety case and how it become a related safety case of big things. So these are normal things. So before starting to all these things, we say every decision will take, there is some risk of, there is some element of risk is there. So nothing is 100% sure. But what is safe, it is defined by different people. If people are immature, don't know the risk, then everything is okay. People who are trained, they know what is the risk, they will take accordingly. And some are daredevil, they go for all this. So this is where we have to define our risk, what, up to what level. As railway transportation service, we go for it should be safe, but as speed increases, it gives different sort of challenges and capacity also. So, like in main line and metro, our customer is different. Okay, from the contractor point of view or from client point of view, both CUC they are different. So you cannot just copy paste what is required in. If we say in 150 years we are running railway and now it is a yes, they are running railway, and I agree. Most of the things are well settled, documented in a railway. Only thing they are not well connected, or traceability is not maintained as per this one, or we have not defined our own. We should not be ashamed of what European do, we are American and do. We have done very good job, but now expectation of increase in speed come, number of passenger comes, so there is a need, different challenges. And apart from this, we don't have a regulatory push. That is a very important we find in China. From final to end, they have every subsection they have defined. People are there to do everything, which is we are lacking. We will discuss that why this safety case is taken so lightly, and it is just a filling the gap in the last moment when CRS is there. So every time we have to take, this is informed decision we have to take, and we should be aware what the risk involved. So what is risk, hazard, safety? These are all become part of your safety case analysis. Safety case. Now we are coming to main thing, safety case, because it is a very structured document. It is cover each and everything. One cannot go away with any of the proof for the claim they are making. So it is very structured. Earlier it was EN 50129, which is basic for hardware part, but now EN 50126 2017, this has come in EN 50126. This safety case is taken there, and it is definition of system. So what is the architecture of the system? What is the environment of the system? What are the subsystem of the system? How they are connecting that one? They are well defined. So selection of that one. Then quality management report, because by name it is a report. Then what is the quality? Most of the people give it like ISO 9001, but that is for company. And if we say something for the company, they are doing one product there. When they go for a project, then 10,000 ISO 10,003, where a different specific objective has to be complied to be achieved within the time frame. So here, when we go for project, it is a 10,000 certificate. Most important part of quality management is not only to define what is the quality we required in the this one. So this quality, people, process, and product, all quality, people quality, process quality, project quality, how it's at the end, and important thing is change management, configuration management. There may be many changes from the very beginning. There may be some changes. So after baseline, if there is a change, how we have tackle those changes? Who are the authorities giving approval? What are the risk analysis and that one? So even impact analysis is done. So and internal audit we do different types of, so different stage audit are taken. So all proof has to be given, because this document say what is my claim, what is my proof. It is not it will be done, it has been done, and this is the proof. If somebody say my product is still certified and for that we have done this one, so product so compliance has to come here. Third party safety management. It is a management. So how we have managed safety? What are the people involved? So trained people involved. Then there is a independence. We will see that one. How validator must be independent if it is a cell 4 or cell 3. It should not be reporting same project management. What are the process we have identified in safety management? You have heard of FMECA, RBD, fault tree analysis, event tree analysis. So all those methods, whether an HAZOB, etc., whether we have planned it in our safety assessment plan and then how we have done it. So this is basically a report. We give the reference of that one and conclusion. Technical safety report is a part which is very important in the sense, here comes the main, because this part itself is a document. We will see that one also. So here not only your technical solution calculation we give, but also safety related application condition. SREC they call it. Because once these are the condition, if you comply this one, my product is up complying to certain seal. So all safety, when you are doing this is to be done sort of things. Then related safety case, it is a sub part like signaling. If we say it is signaling whole is as a cell 4 or cell 3, whatever you take it, then say AFTC. It is a sub part of whole signaling system. The AFTC safety case become the related safety case of this. And you can just see here we don't give the define, but only the references and conclusions, because everything is not so rosy. When we go, we have some conclusion, we have some recommendation also, and these recommendation from functional safety point, not any design, because that will be done. So when we are going for safety case preparation, etc., we see what is the system life cycle phase given in EN 50126. In 1991 there were 14 phases they have given. In 2017 it is 12 phases is given. So when you go there, first concept, any product first there is a concept and proof of concept, then they have defined safety definition, when it will be operate. Then we initial level analysis, the evaluation phase come, then we go for specification of system requirement. Here we define system requirements are both technical and functional. If we say software system requirement, if our product also having software, then software system requirement, hardware system requirement. So because this is very important document when I go for final this thing, so whatever you have written in your safety requirement specification, then we have to say up to last level, if this is required, whether the compliance is done or not, what are the proof that it is done. There may be testability of it is expected that the most of the requirement should be testable, but there may be some of things we have to see another way to confirm yes this requirement is fulfilled. So that is one traceability matrix. So whatever we do, claim it whether it has been complied or not. Particularly, I will say if it is a SIL 3 or SIL 4, etc., EN 50128 for hardware and software, and 129 for software, they have very defined things. So I give there a checklist sort of thing. You have to confirm yes, this has been done or not done. Fifth is particular architecture apportionment. So here comes the after our specification we define, we will, because system has to be modular to the extent possible. Okay, and there is a well-defined things are there. So when it is a apportioned things are there, we also define the reliability apportionment, also safety assessment, also the subsystem which are very critical. We will define that in system architect, we give the requirement a portion. Then we phase on the design phase. So here comes actually the design. So whatever specification we have defined, what are our requirement given? Like in a contract itself, we have written this is the things that this specification to be followed. Normally, like system engineering, there is IEC or ISO 15288 they give it. Yeah, this should be thing. Then there is a signaling requirement. They give signaling requirement. Rolling stock they give the rolling stock, and draft. So all requirements with the with the standard they give. So we can later on trace what are those requirements, because this is the first requirement. If they are complying to the standard, then only go for another things. You will see in a safety hazard identification and compliance. We'll see that one. Then we'll go manufacturing, and I will go manufacturing and purchasing, etc. Because whatever design specification we give, whatever design you get, whether we are, if manufacturing, whether manufacturing process are complying to those one or not, whether manufacturer is vitiating it or not, even we are going purchase, our purchase order should be same what is required in design. So approved things are not there. It is just not should be the कोई सबसे सस्ता किसने दे दिया उसका ले लिया ना, whether they are complying to those technical requirement or not. Then comes integration, system validation and acceptance. So most of the thing railway also do it. Only thing they are not following this process, but in our life we have seen many things we have done, and later we realize why we have done. But that's definitely we are doing. Unfortunately, that is not guidelines. So there is so much documentation required. Like Narayan Murthy say, in God we have faith. All other has to put document on the table. That means everything. It is not I am not trusting you, but I trust your document, because this is the document which is a continuous thing. I may not be there, you may not be there, but document will be there, and this is where you will design the products. So this is the V cycle. It's the presentation of same phase system life cycle in a V curve. So you can identify from product to step by step, because there is a verification plan. So in every phase there is an input, and there is in every phase there is an output expected. So whether we are achieving those output or not, whether we need some correction or not, input is required, change is there. So how these things are given. So every phase there is a verification and validation. As I told, system requirements vision. When we go for validation fit to purpose. If we require to whether it is site, like you do na site acceptance test. It is a site acceptance test. What you will do, that should match to the requirement given. Yes, it is not only this image, it should not give something other also, because there is a many things which engineer cannot imagine. Like one of the thing I said, where this washing machine, Japanese washing, Korean washing machine was too much popular in India, and all of a sudden when they have come, they find there is a problem in particular North India, particular Punjab and that region. They have searched out and they find instead of using washing machine for washing clothes, they were preparing lassi. Okay, so this sort of challenges also come, and that is a one you can say good thing in Indian environment. Ki our user is so innovative, they can use, misuse and abuse the same system. So this is where we have to very careful, not only requirement, but it should not be misused. So this is the same life cycle curve they have in V, because it is very. Now I come to main topic where there is so much confusion. Safety case. People say safety case bana liya hai. What safety case? It is general product safety case, a specific application case, or general application safety case. So normally you see this middle one. General product safety case. Same, it is like what is the life cycle phase are given, same life cycle phase, and there is a validation report. If you see in between whatever product any company is offering, they give the validation report. And in their safety certificate, if there is a SIL 4, one thing we have always see, whenever they give safety certificate or SIL certificate, they give the reference of safety case or some validation report, yeah, some assessment report. So because this certificate is not independent, because when you go to that safety case, you will find there are many conditions, many assumptions. Okay, whether those assumptions are is as per requirement, or we have to comply those assumptions. So when you are taking safety case of any product, just don't go for their certificate SIL 3 or SIL 4. What is the safety related application conditions are there? Right, so most corner you will find when you go for product, because in India most of these design, manufacture, installation, testing, commission, these sort of contracts are there, tenders are there, in which case company bring their product which are already certified, and then based on that certificate, and then they go for design and implementation phase, etc. So here we have to see in our product, our project, whether our design processes or whatever resources we are deploying there, they should not visit the SIL level of the product. Not only there, but later on in manufacturing phase, installation phase, because here comes your specific things requirement. One of the question which was asked, whether if any reliability study done in one sector, whether it is sufficient for other or not. We have to be careful in every section, what sort of similar and what are the changes, different things are there. If there are changes, you have to take care of that one. So normally what the CRS level, let's go, these are basically operational safety case, where the final up to installation, testing and commission, that report as the part of it. If the general product safety case, you will find mostly on design related and manufacturing related SRX are given. But when we go further, then our process, purchasing, how we are purchasing the thing, whether we have purchased correct or not, whether like we go for FAT, etc. We have done the FAT, then FAT reports are there. So this is the proof that whatever we have designed and as per specification we have asked for supply, they are correct. Okay, then we go for installation, whether processes are there or not as per our installation plan, because they are also approved. Then the installation report, where the checks are there somewhere. Then we go for testing plan, how you will going to test it, who are the people who are involved in the test report, etc. So all those proof report will be part of your operational safety case. So we hardly find people give just we have seen in this one, because now our ISA and companies are too smart, they know they take advantage our lack of knowledge on this thing. And but if we go this here in my project, I got it done. One of the supplier, rolling stock supplier, to include third party ISA and get that report, because in their contract they were claiming in my brake system, TCMS, fire detection system, door system, they are SIL. Then I asked, okay, if it is a SIL, you give me SIL certificate. But they did not have. They later on engaged the patrol. They have given the report and they have complained, that will be carry forward. So these are the types of safety case which are here in safety case, etc. Always remember, safety case is for product first. So there is a phase, life cycle phase of the product. When we go for project, how it is as a design something, then installation, then testing and commissioning. So we have to map one to one. This traceability very important. Yeah. Now I coming especially defined in the definition of safety case. This is the first part of the safety case. Here I highlighted the boundary condition interfaces, because all other system you can write my system is such, it is for this project, it is for this is the other subsystem. But what is the boundary condition and interface? Because here we are, all products are very good, but chances are there when they go for interface with other system. Here the hazards condition will be more. Like your platform skin door, we say platform skin door SIL 3, SIL 2, it is product, because part where the controller is, door controller is SIL2, and most of the company give it. But when they interface with signaling, because all Geo4, where automatic train is there, driverless train is there, then signaling system will command to the door system, it should be open or close, whatever it may, that is SIL3. Okay, so for product development, they have to follow SIL2, what is the requirement, and for the interface, they have to follow SIL3. And we see what are those things are there. But when you are defining, when you are looking any safety case, you first say what is the system, what is the environment, what is the boundary condition, and what are the interfaces doing. Second part, it is a quality management report in which, because it is all claim, and auditor or ISA never asks you do this. It is only what I claim and what is my proof. They will, so it is auditor's job is what you are done, you give me a proof, yes, you have done it correct, and they will confirm, yes, this is their claim, they have the follow, and this is their compliance. Okay, so what quality management safety system activity you have done, then that should be appropriate to the your requirement. Yes, this is my requirement, this is we have done. Then here you are in this safety management, you don't have to give big reference, but you have to give reference of your quality management plan, change management plan, a configuration management plan, because these all come from safety plan also. Because in safe, when you define your system safety plan, you already commit, this is why things will be there, this is how I will going to handle the things with what product, what document I will prepare. Even design management plan become part of this one. In design management plan, if you see, there is a input output also. What are the tool you will use, technique you use for design, what are the design process are defined. When you there is a change in configuration, then you see configuration management plan. When there is a configuration changes, how it is going to take in. It also give the what is the NCs and non-conformity. It is non-conformity with respect to standard. So you have to give proof. Yes, this has been audit was done, and this is the non-conformity and how it is been low. So this safety case will give only proof of quality management in quality management report part. When we go for safety management report, say whenever we say it is a management, that means it's a whole people, process, and product. Whole thing, how we are doing, who is doing, how we doing, why doing, everything is there. So in safety management report, first thing what you have claimed in your safety plan, what are the method you have, what was your subsystem, what are the method you have used for their hazard analysis, etc. So these hazard analysis, normally when product is there, they go for hazard log one document, it's sufficient. But when we go for project, better project, you will see there are preliminary hazard analysis, then system has subsystem hazard analysis, because there is a detailed analysis, you go in a very deep. Then there is a interface hazard analysis, because interface is a one area where most of the hazards come up. Because you just transfer to other party, and whether they have complied is not is a difficult job. So it is required a deep traceability. Then there are operational support hazard analysis, because this is operational support hazard analysis. Here we say how my operator, how my maintainer is safe. So because from there you will find this most training manual come, operation manual, then maintenance manual, these all comes. Even emergency safety plans, etc. that is come up. So all these is the product of your hazard identification and the report of that. These are the some of the management issue, role, responsibility, because this is very important. We find people submit their safety case and then find their organization is not, because there should be like safety engineer, then there should be safety manager, there should be approval part of thing. So like in railway we do a 3-stage checking. So we have to well define what is the role, what is the role of first one, what is the responsibility of first one, what is the responsibility second one. If we define these things in a very systematic manner, most of the time, because क्या है, safety आपको नेचर में लाना, it should be your next second nature. आदत बन जाएगी तो सेफ्टी अपने आप कवर होने लगेगी. Because in railway we see, you don't have to say you are maintainer, you are subordinate कि कल GM inspection है और आपको आना है. They come in because they own it. So when the safety thing, it is same for designer also, because they should see कि when I am making design how it should go, when I am going for install how it should be, how my customer will see, because there is so much internal customer also that we have to take care. Then next part come is a technical safety report. In technical support, this I find it is a very important part from the point of technology we are using. Like earlier, it was solid state interlocking. Okay, so whatever interlocking, whatever signaling we are doing, and whatever the way we are communicating to our final customer, means driver, was different. Now CBTC has come. Now you see, EN 50159 is very important. Because there is communications, how you are communicating, CBTC, there are so many wireless things are there. So in design become part of, not only communication, if like if it you are doing for rolling stock, then fire safety is a very important thing. In all electronics, EMC is a very important thing. So why you, how your EMC management plan was there, how you have designed your sync and source thing, whether your system is safe enough to work in the environment. So EMC test, C certificate, etc. are there or not. If it is a fire related, like rolling stock, we say there is a, if there is a inside fire, fire should not go to the top, means above the floor. Then from the selection of material, because EN 45545 is particular for fire. So everything is given there. How you are use upholster, you have select material selection, test, etc. Smoke, etc. Because this is also important for your telecom cables. If there is a fire, it should not give smoke, such thing people cannot get be saved. So you save time, you have, we can give. There's the same thing for tunnel ventilation, because the so many cable they are using. How it can be safe. Then related safety case portion. This is the subsystem. If you take any system like rolling stock, the TCM, train control and management system, or brake system, it becomes subsystem. If you say your power supply system, then SCADA is, because now SCADA, you say so many project is going in India. Kavach, we will discuss that one. The train 18 is also there. The TCM is very important. Electrification, SCADA. Now government of India, power ministry has given about 2 year back, well, instruction for safety of SCADA. There were so many grid failure were there. Then they have come up with what are the guidelines are there. Railway ministry also given to RDSO. There are the some of the guidelines, because they were related with security, cyber security. Because SCADA is, you see, so many PLC we are using. Our tunnel ventilation, air conditioning, etc. So there is so many PLC is there. So PLC, now those PLC certificate have their safety case. They have their limitation, their assumption. So all those assumptions have been taken care of not. So it's this related safety case. If we are going for tunnel ventilation, okay. So tunnel ventilation safety case in which the PLC will be the related safety, where the assumption will be taken care of in the project. Now, as conclusion, because most of the time it is conclusion, everything is good sort of things. People say simply in our project, even now our culture has molded to ISR to such an extent if they become pliant to anything. That they also in a business, they are contractor. Okay, so they give every rosy thing. No, when we are paying, we are not only finding rosy thing, but what are the risks is involved. If I know my risk, I will be prepared to handle it. So every safety case, you see what are the assumptions are there in the design stage. What are the assumption in installation? What is the assumption they have given? So first, compliant to the assumption. After all hazard analysis, risk analysis, whatever method, HAZOB, FMECA, whatever you take it, fault tree analysis, you say that's what is the resistance, what is system dependency. Normally, even ISA and most of the supplier give, okay, fault tree analysis, it is still for, because we have attained 10 to the power 9 is uh, failure per hour, affecting failure. That is not sufficient, because that is a whole process. It is not the end things. It is the process. How you have prepare your safety plan, whether you have taken everything in a safety plan or not. If there is a change, how you have adapted to the changes, how you have handled your configuration management. When you are using any tools like in manufacturing, whether they are calibrated or not, because now you many things will come where you have to see things are calibrated or not. So, and calibrate where there is so many like welding work with the rolling stock, then welding standard has been complied or not, test are people are skilled enough or not, then you give the recommendation. Here one thing is this recommendation not up yes motherboard ले लीजिए, no, that is not, that is a conflict of interest. Your recommendation should be only based on functional things. Okay, you have to make not design related issue. Now we come to safety case and project, because this is one thing where people get confused. If there is safety case and project, whatever go for CRS level, final approval level, that is like project safety case. They're all design related compliance, installation related compliance, means safe installation plan to installation report, TNC plan to test TNC report, and they are for ready for commercial operation. Normally, in a general application, general products, we say it is a baseline. Then somewhere you go for installation, but normally we did not get, and they give final thing when you are going for your design. So it is all safety case for functional safety. It is a technical safety for functional, because our goal is from customer point of view. Those functions should save, and this customer is not only our passenger. Our customer is our operator also. Customer is our maintainer also. So everybody should be safe and secure also. Technical things will take it. What technical solution we are giving, that we have to take care of. So when we go for EN 50126 for the safety case, we have to take hardware and software into consideration, because this is the fundamental of our product. Okay, so EN 50128 for software related thing, 50129 for hardware related thing. And now CBTC and communication as EN 50129 also, and I add now ES 50701 also we should take, because there is so much cyber security issues are there. You can tweak to the ATF, and you can see there is a jumble of train on the there is no train on the side, but your system is showing that sort of things, because that is well aware. In 2010, Iranian nuclear power SCADA system was tweaked. It was the PLC of Siemens, and people and experts say it is from Israel or USA. They tweaked to the system in such a manner their turbine this movement was showing different in inside and in the safe side. So there is a very tricky issue. Now when we say safety, we have to be seen in a total manner. So now six, those things will also come just for this one, because this is a hardware related engine. Earlier it was in 50129 safety case. There is a annexure E which give what sort of technical measure you use. Like in any job application, or when we go for employment, they say where you have passed out your engineering, we have done your 12th, where you have done all those. ऐसे ही उसकी पूरी बही खाता निकाल लेते हैं, जन्म कुंडली. So if people are well trained from the very beginning to do certain things, there is a possibility they will give the desired result. Same thing goes with the product also. If you are using proper manner, all systematic here, because most of our from our tender document, there is so many conflicting things are there, and there is hardly anybody is reading that one, what is written in one page, what is written in the same document in other page in the same document. Let alone the interface, what is written in your rolling stock document, tender, what is written in the signaling document. what is written in a rolling stock document, what is written in our traction document, power supply document. So if those problems, these are very systematic failures and very difficult. It is time consuming. And what Mr. Ajit was telling, 2% or 4%, yes. Where we lack is our legal, we can say, some sort of government instruction, because these things, this document is still not aligned. What I am preparing safety case is not actually going to the CARS. Okay, what is not actually asked by RDSO. When 2013 RDSO first issued this requirement for approval of a metro in India, you see there is only one annexure is there, where is only written signaling should be SIL4 and there should be ISA, etc. People are going for ISA only because metro has to take ISA for this one. That is why they are forced to do it. If RDSO asks for another thing, there is a many other thing will come. Say it is ultimately it is the economic of the country. Okay, where is come transportation? There can come the railway. There is a means of process. So how our people are using our system, it comes to whole circle. The effect will be like so. If government guidelines or rules are there, people are forced to do it. Now we see there is so many rolling stock ISA is also coming, even PSD also coming. So gradually it is coming, but it is taking time. What is the things I told in a technical safety report, which are the part of our safety case? Here you find there is this document, technical safety report itself is a big document. Here we see single failure should not affect sort of thing. Those things will give assurance, redundancy. We talk about redundancy, path redundancy, root with a root disability, hardware and software redundancy. Then a hot standby, cold standby. How you are selecting? Because ultimately it is like your response time. By what time you want something to be done? Okay, and this one section 5 of this technical safety related application condition, because this is the condition which must be written along with your safety certificate. If it is not written, references has to be given, then only your safety case is acceptable. We have rejected many safety cases only because they were in our project it was 25 kV, they were giving safety case or safety certificate for metro, which is having DC power supply. Okay, so environment is there. So this is very important what we are getting. Another thing which is coming in related application is EMC, etc., fire, etc. What other thing, critical things are coming that become related application? Environment is very important because most of our server, etc., fail when say European conditions say they say -10 degree to say 25 degree. Now our normal temperature is now going 35, 40. So our system are in stress. They are environment stress. Temperature, humidity, everything is changing. Whole design we have to take holistic approach. Now coming to the safety case, because it is all about risk, it is all about hazard. We say it is a failure. So there is systematic failure and random failure. So random failure and systematic failure, then say integrity level. These are we take into consideration in design, etc. And as I told, safety case is not sufficient if there is no safety case. Safety certificate is not sufficient if there is no reference of safety case. And no safety case is acceptable for the cell if they are not complying the specific method and tool. There is a combination of tool and method in EN 50129 they have given. This has to be complied. So this is any questions are there, I am happy to take it.
Thank you, sir. If there are any questions, people may ask.
Sir, this is Rajiv, CSC. I just wanted to ask one thing. You were referring to CRS documents. Does it fall under functional safety requirement case?
No, if you see CRS requirement, they just give one particular for signaling. They give the safety case for ISA or safety report from ISA. That is insufficient because our CMRS or CRS, they do not only go for only functional level, but they go for design level also. They ask so many design document also. So it is insufficient. But what is the thing is that what is the safety case they are asking and what they are getting? Say, in that safety case, what is the content? That is very important. So whether all proofs of our say testing and commissioning plans and their reports, because what plan we have given, what is the reports are, whether those are correctly checked or not, the testing commissioner. Because testability, as sir has told, testability is very important. How much test case we have prepared, which are which are the you said our functional requirement case was there. And if it is not testable, how you get the confidence that it will work? So all those things, if CRS don't ask, our client will not ask, our contractor will not give, because contractor, why they prepared so much document? I tell you, in our project, first year only we have got some of the documents from some of the reputed, like Alstom, etc. Given. Even they were not sufficient, but at least they go. Other people like lift and escalator, they don't find, because we don't pay them also. So if we don't pay them, if we don't connect to their paying, etc., they will not do. Another thing, they don't know what to do. We find out very case where their HSC is given, health, safety, and environment, etc. Because this is the system safety functional required. So our target is very clear. It is a system. So whatever system, whatever we define the system, that will go. Neither our RDS is asking those details. So even then we were in touch with that one, but regular things are not there. So system, but say people are struggling doing their work at their level, and it is said कि safety is up to that level. If everything goes on, it is said जिस दिन मिनिस्टर ने कहा कि झंडी हिलाना सब काम हो जाएगा. So this is another thing, because in our system, whatever thing we are doing, people are doing very hard work. I was because one of two things I say, when Gaisal accident, I was the DST Malda in Eastern Railway, and I see the heat. Because for 2-3 years we will not get proper sleep, because it was such an accident. It has shaken the consciousness. The day driver lose the confidence on signal, we are of no use, whether we are a ESM or CST or whatever it may be. So those confidence, losing of that confidence is very important. And at that time, our boss has told me, and this was a, we have to see all the station working rule, our drying, our people to be there. Then in a limited time, we have done all these things. Later on, what we have missed, it is because Gaisal, etc. in that section, we find also there were the station working well were not updated more than 4 to 7 years also. So there was a systematic failure. So if our system is there, our people have updated references, there are less chances, more on training also. So those things they have told we are. Another thing, the way we see our safety. When I was in ACD from 2003 to 2007, and Satyana sir was at the board, etc., I got some attend. Because I find our Jalandhar Amazon driver have given training on this. But basic level, they know how to use the things. There may be many failure. Their specification were different, requirement was different. All those things are there. But later, I am very happy. Like my batchmate Lalit Mansukhani and team has taken in RDS one, they are now taking it, because now this is not ACD. Kavach is altogether different solution, function, improved function, system architecture change, and it is meeting the requirement. But here also, I say, if you are saying your loco equipment, loco ACD, I will say loco equipment is there. This has the safety function. They have their safety case. Similarly, their station equipment, they have their safety case, their safety functions are there. Now, whole system will come. We have to see each and function whether it is traceable from your requirement, because so many hardware and software is involved there. And now security is another issue. How we are handling with it. Huh? Is, third thing which helped me to understand the in ACD how software fellow understand the take the risk, like point they were taking, yes, this is the my we will say it is a deviation etc, but don't see it is a risk factor. So when we say anything is risk, then we come to know, yeah, this is how we are taking our different challenges in a different way, because solution is getting different, more technicality is coming, so we will find yes, there is a other way to see it, but solution will be here. Any questions?
Well, I'll ask one question, Rajesh.
Yeah.
That even if, as per our requirement, a very good document has been given by the suppliers, is our people professionally has that aptitude to verify whether it is okay or not? Why I am telling, just after UFSBI and everything was there, AC Gupta sir मेरे को task दिए थे, every document, every page, I had to see and I had to certify कहाँ ठीक है कहाँ गलती है. You take another very simple thing about the train drivers. I found about 45 to 48 causes of the drivers to make mistake are there. You take one thing, if a driver runs over anyone or there is a suicide, so he will get trauma. But our drivers are still forced to drive the train next day or maybe in the same day. Number one. Number two is that you take the case of this location huts. As soon as electronic equipments just like axle counter, EJB, all these things came, some people started thinking कि equipment size तो छोटा हो गया तो location box, half location box. But as soon as half location box is used, your air space got reduced 4 times. So natural air cooling is not there. The system will be, reliability will go down. So they didn't think of the alternative that in this case at least the location hut must have heat reflecting paint. So these are the fundamental things. And another very vital thing, because you are working with all these, I'll just tell it. It has been researched and that after 3 hours 20 minutes, if a people works under stress, then for 15 minutes his or her brain does not function. Now take a curve area with a gantry, lot of signals are there. If your driving schedule is such that the driver will come that place within that 15 minutes, there is every possibility of. So इसमें बहुत research करने का है. People should come forward. That's why I'm telling. Academics को लाइए, connect with the universities, let them do the research.
Yes, so sir, yes, exactly, sir. So नहीं से I also work in railway and I've seen some of the things. दो चीज मुझे लगी है. एक तो है क्या सिस्टम हमारे लोगों को चाहे ऊपर से नीचे ईमानदार होने का मौका देता है. पहली चीज है ना, हमारा कुछ भी रूल हो, वेदर इट इज इम्प्लीमेंटेबल और नॉट, है ना, यदि उसमें कोई गलती, एंड देन देयर इज अ मेनी थिंग वी हैव टू डील. व्हेन आई वाज a project manager for Expo 2020 दुबई मेट्रो, एंड बहुत सी चीज रोलिंग स्टॉक से आता था, ओसीसी से आता था, ट्रैक्शन वाज देयर डेफिनेटली. तो हमने जब, क्योंकि मेरा अनुभव रेलवे के बाद में मेट्रो जैसे मुंबई मोनोरेल का पूरा टेक्निकल डिजाइन, टेलीकॉम डिजाइन किया था एज ए लेड इंजीनियर. तो फिर देखा कि नहीं, हमारी बहुत सी चीज़ हमें डील ना करने का कि हमारे पास है बहुत ज्ञान, बट उसके बाद यदि हम सुनते हैं, जैसे आपने सही कहा कि हमारे नीचे के लोगों से सीखना है. जब मैं 97 वगैरह में डीएसटी था, तब मैं देखती हूँ वहाँ का मेंटेनर बताता था कि हमारे पास जो सिस्टम है ये फूड पोर्न सिस्टम ब्रिटिश सिस्टम वाले हैं, और जब हमारे मेट्रिक सिस्टम आया तो हमारे दूसरे सिस्टम आए तो हमारा पॉइंट मशीन एडजस्ट नहीं हो रहा है, लॉक नहीं एडजस्ट हो रहा है. सो कई बार हमें ये देखना कि यस प्रॉब्लम है, बट ये है कि हम ज़्यादा एक्सपोज करते हैं लोगों को. देन क्योंकि जब हमारा जो अनुभव था, जैसे फरोजाबाद एक्सीडेंट के बाद जब हमारे डिवीजन में जब एडवांस स्टार्टर शिफ्टिंग का बात आया तो पूरे इंडिया में 125 एडवांस स्टार्टर जो थे 180 मीटर से बाहर थे, मेरे यहाँ पर 83 थे। देन माय बॉस हैज टोल्ड, बसु साहब ने कहा कि राजेश आई विल शिफ्ट टू यू, आई यू शिफ्ट एडवांस स्टार्टर। आपको लगता है इंडिया में तो आप ही हो जिसके यहाँ इतना खराब है? मैंने कहा सर मुझे पता नहीं है, पर हो सकता है मैं ही सबसे खराब हूँ और मेरे जो भी सबॉर्डिनेट थे और वो थे, उन्होंने कहा कि साहब 183 मीटर उसको भी उन्होंने दे दिया कि साहब ये आउट ऑफ 183 थे, मैंने कहा ठीक है, वी हैव टू सी इट। तो कई बार हम आप ज्यादा एक्सपोज कर दे तो हम देख से था कि प्रॉब्लम है। ओनली थिंग इज इफ वी नो द प्रॉब्लम ग्रेजुअली से वी लाइक आयसा वी गो फॉर दिस मेट्रो say we respect the designer. First thing, we have no doubt on their credibility and their technical know-how. Okay, now how they say our approach is how they get their own solution. मैंने बहुत बार देखा यदि हम कहें कि तुम ऐसा करो तो पीपल नहीं करेगा, हम कहेंगे यार नहीं आप यदि ऐसा करोगे तो ऐसा हो सकता है। लेट देम हैव अ ओनरशिप ऑफ देयर डिसीजन। और उसके बाद यदि उसको कहोगे कि नहीं आपने अच्छा किया, ये आपका डिसीजन है, यू हैव डन इट गुड, देन पीपल ग्रेजुअली दे स्टार्ट आवर मतलब हमारे यहाँ का सिस्टम ऐसा है ना कि अभी हम भी फूड प्लेट करते थे, जब वॉकी टाकी आया था तो देखा कि जब लूप लाइन से जब गाड़ी निकल जाती थी तुरंत गार्ड बता देता है ड्राइवर को कि हाँ लूप लाइन क्लियर हो गया और वो स्पीड पकड़ लेता था, पंक्चुअलिटी इंप्रूव हुई। तो ये हमारे गार्ड ड्राइवर या कोई कम्युनिकेशन के बजाय पंक्चुअलिटी में ये फर्क हुआ, ये हमारे जब गए लाइन पे तब देखा। तो देयर आर मेनी फैक्टर, so our system we have to see people, we have to give time to correct it and we do not punish for their मतलब openness also। आता है हमारे यहाँ पे बहुत प्रॉब्लम है, वो प्रॉब्लम के बाद हमारे सॉल्यूशन भी उतने हैं। तो वी हैव टू हैव कॉन्फिडेंस ऑन आवर पीपल आल्सो। वी फाइंड जैसा आपने कहा कि बहुत से लोग जो आए हैं वो उन कॉम्पिटेंसी से, वन थिंग जब आपको कॉन्ट्रैक्टर देता है तो वो जो भी देता है व्हेन भी हम क्रॉस हमने कहीं उन्होंने डॉक्यूमेंट दिए अप्रूव्ड थे, फिर हमने कहा नहीं साहब आप देखिए आप ही क्लेम करते हो ये होना चाहिए। हमारे यहाँ एक ऐसा हुआ कि जब आयशा ने भी अप्रूव कर दिया कि साहब हाँ इनके रोलिंग स्टॉक के सब डॉक्यूमेंट ठीक है, फिर हमने आयशा से पूछा कि आप सिर्फ एफएटी के बेसिस पे इसको सील दे दोगे क्या, इसमें ये चीज कहाँ है? आप मैंने चेक लिस्ट दे दी, मैंने कहा आप ये चेक लिस्ट आप क्लेम कर रहे हो कि मेरा ये सिल 4 है या सिल 3 है, मैं आपको चेक लिस्ट देता हूँ ये 0126 का 129 का, आप भर दीजिए। ये इसमें जो भरा है, बिकॉज वंस पीपल गो ऑन राइटिंग पेपर दे आर वेरी अलर्ट, हाँ क्या लिख रहे हैं, है ना। तो हमेशा उनको दो। मैं कभी किसी से एज ए ऑडिटर आल्सो ऐसे थे। दूसरी चीज है कि उसकी कमी हमारी कोई स्ट्रेंथ नहीं है। इफ दे गेट अंडरस्टूड ये चीज ठीक होना चाहिए तो हमारा काम भी कम होगा, तो टाइमलाइन भी हमारा कम होगा। तो कई बार ये होता है कि ठीक है आपने कर दिया, बिकॉज जैसे आज से कि बहुत से लोग बड़े दुखी थे कि एसीडी फेल हो गया, बट ऐसे कि ओके एवरी फेल्यूर हैज अनदर स्टोरी, आईपीएल का भी अनदर स्टोरी था। यहाँ पे यदि एसीडी फेल हो कॉन्सेप्ट था ठीक है, बट वी एज ए इंडिया एज ए इंडियन रेलवे कम अप विद अ बेटर सोल्यूशन विच इज रियली रिक्वायर्ड है। और हम ये मैं बहुत समय से कर रहा था जो अभी अजीत जीत ने बात की है, और ये वाला इसमें ये क्या है कि मैं जैसे दुबई में था EN 5012 के अनुसार उन्होंने अपना स्टैंडर्ड बना लिया, हम भी बना सकते। और चूंकि ये गाइडलाइन है इसका मतलब यही फॉलो करना जरूरी नहीं है। हमारे यहाँ की कंडीशन जो है हम धीरे धीरे, और हमको क्या इंडस्ट्री के साथ इस देखो कॉन्ट्रैक्टर को हम स्टेक होल्डर बनाएंगे, वो भी आएगा बात करेगा, उसकी टेक्निकल नॉलेज उसके पास भी है, हमारे पास मैनेजरियल थिंग है, हाउ टू गेट इट। कोलेबोरेशन से बहुत सी चीज निकल के आएगी। तो जैसा से EN 5012 हमारे ये भी निकल सकता है, कोई इशू नहीं। जैसे हमारे कहते हैं रेलवे में ना कि ये 505128 सेफ्टी सॉफ्टवेयर का है, ये दे दीजिए। बट हमारे पास आते हैं, आई टेल यू, बिकॉज सॉफ्टवेयर itself is a big industry itself. Okay, they have very good, they have like a 12207 standard is there, and there are many standard they do it, so we respect that one. Yes, यदि आप अभी हमारे यहाँ हुआ एक डिपो इक्विपमेंट फेलियर देखो, सप्लायर को भी EN 5012 सीख देते हैं। उसने कहा साहब मेरा क्या है, मैंने कहा साहब आपके मशीन में जो सेफ्टी करते हो यू ब्रिंग दैट वन, आपको मैं आई विल मेप इट, I will map it how you are in design state, how you are complying to this thing, whatever जो क्लेम आप कर रहे हो उसको ऐसा करो। तो आपको धीरे धीरे लोगों को भी, बिकॉज ऐसा है कि यहाँ क्लाइंट को भी बहुत बार समझाना पड़ता, क्लाइंट भी नाराज हो जाता है कि अरे यार क्या लेके बैठ गए, हाँ निकालो इसको, है ना। फिर उसको समझाना पड़ता कि नहीं ठीक है सर। फिर उसको फिर आपको क्योंकि मैं ये देखा जैसे चेन्नई मेट्रो में था तो शुरू में लिफ्ट एंड एस्केलेटर ये टन वीएसी वेंटिलेशन, उसने कहा साहब हमको एक पैसा नहीं देते हो, गाली दूसरी देते हो, हाँ, और उनको 20 लाख देते हो रोलिंग स्टॉक को। हमने कहा ठीक है आप बैठो, मैं आपको पूरा फ्रेमवर्क बना देता हूँ, आप इसमें पॉपुलेट कर लीजिए। पॉपुलेट करके धीरे धीरे तो हम एक ये मैं कि यदि हम उसको फ्रेमवर्क दें कि हाँ साहब सेफ्टी प्लान बनाओगे तो ये लाड़, अदरवाइज अभी भी आपको दिल्ली मेट्रो के कॉपी पेस्ट मिल जाते हैं। इट इज नॉट दिल्ली मेट्रो वाज बैड, पर 2003 इनिशियल लेवल में उनके पास जो नॉलेज था, जो इन्वायरमेंट था, दैट वाज क्वाइट डिफरेंट देन टुडे। ओके, सो अभी अभी कई जगह जाके हैदराबाद मेट्रो का कॉपी पेस्ट मिल जाता है। तो हैदराबाद मेट्रो इज टोटली डिफरेंट, इट इज अ प्राइवेट लाइक सॉर्ट ऑफ थिंग, हाउ दे आर मैनेजिंग, हाउ दे हैव स्टार्टेड विथ थिंग। पर हमें अपने इन्वायरमेंट को देखना होगा कि वहाँ सेफ्टी कैसे हो रही है, डॉक्यूमेंट कैसे आ रहे हैं, वी हैव टू हेल्प। अभी हमारे प्रोजेक्ट में सबको 30-30 डॉक्यूमेंट दे दिए। अब बताओ कॉन्ट्रैक्टर क्यों देगा 30 डॉक्यूमेंट जिसके लिए उसको 10 लाख मिलेगा? ही विल पुश इट और वो कहेगा साहब आने दो समय, जिस दिन डंडा पड़ेगा तो सब ठीक हो जाएगा, सब लोग अप्रूव हो जाएगा। तो बट उससे डंडा पड़े, हमने कहा कि साहब ठीक है आप बैठिए हमारे साथ बनाइए ये प्रोजेक्ट में, ठीक है आपका कंप्लाई हो जाएगा, और आप ये किसी प्रोजेक्ट में जब जाओगे तब इसको लेके जाओ, बस अपना डाटा चेंज करें। आज से आपका मोस्ट ऑफ द प्रोडक्ट लिफ्ट एस्केलेटर एएफसी बहुत सिमिलर है, तो उनके साथ वो भी मतलब ये है। एंड बिकॉज अभी हमारे जैसे बहुत से अजीत जी भी हैं और राजा गोंडन साहब भी हैं। अभी लेटेस्ट 7th और 8th को मैं हैदराबाद में था मेट्रो का ट्रेनिंग के लिए। वी हैव टू गिव द इन्वायरमेंट, और ये चीज़ है कि नहीं ऐसा हमारे यहाँ कुछ नहीं होता है, ऐसा भी नहीं। हमारे यहाँ लोगों को ये कॉन्फिडेंस देना कि आप काम करते हो, बहुत काम कर रहे हो। हमारा नीचे से लेकर मेंटेनर ऊपर से तक लोग लगे हुए हैं। कहीं चीज़ है कि ठीक है हम अपना सिस्टम बनाएंगे, टाइम लगेगा, पर ठीक है मतलब वी हैव टू हैव कॉन्फिडेंस। और बजाय उनको कहो कि नहीं आप यही यूरोपियन में आप वहाँ गलत कर रहे हो, नहीं आप गलत नहीं कर रहे हो, आपको अपने तरीके से सही करना है। हमें इधर के हमको न तो यूरोप का कॉपी करना ये करना, हमें यदि 30-25 साल की सर्विस के बाद ये नहीं पता है कि हमारा स्टैंडर्ड स्पेसिफिकेशन क्या होते हैं, देन वी हैव टू थिंक आवर ओन ना। और हमें जो आने वाले लोग हैं उनको ये बताना होगा कि साहब ये इसको ऐसे ऐसे हो सकते हैं, लेट देम टेक ए रिस्पॉन्सिबिलिटी। आज हमने जो बनाया कल से और कोई अपडेट करेगा ना, दिस इज हाउ इन 10-20 years सिस्टम इम्प्रूव। हाँ, and really there are so many changes has come up, people have come. I seen one of the this I think the lady Miss Agrawal was there, some presentation is reset. Now how they have come quite good for Kavach system. Now European people are also asking ये यदि बना लोगे तो हमारी दुकान का क्या होगा? Yes, we require such people who do the work. We will come up. है थोड़ा परेशानी है, पर सबको ठीक है, चलता है, अच्छा है, समय लगेगा।
Hello, sir. This is Priya Agrawal.
Yeah.
We are running behind schedule,
No,
so I will just keep
yeah,
my
yeah.
questions.
No, Priya, just what I can do, because Dr. Hiral is waiting. So at the end of his paper, we can just, because I think Rajesh, you will be continuing to be available.
Yeah.
I am here, sir.
The
Session. Yeah, so we will just finish it off that one. Yeah. Please postpone the question. Yeah, thank you.
Thank you, sir. Now we have lecture from Dr. Hiralal Ji, Assistant Professor, Subir Chaudhary, School of Quality and Reliability, IIT Kharagpur. He is a postgraduate and doctorate in reliability engineering from IIT Kharagpur, and he has worked in private industries for 7 years, where he had performed RAMS studies and implementation on various railway projects such as Lucknow Metro, Dubai 2020, Grand Paris Express, Shanghai Line 15, Perth EMU, TMU. He has trained many engineers and scientists from industries and public sectors also. His current teaching and research involves RAMS for railway system, functional safety for automotive, system reliability modeling and analysis, reliability-based design optimization and life testing. Today, he will deliver lecture on RAMS implementation for rolling stock. Over to Dr. Hiralal Ji.
Thank you, ma'am, and very good afternoon to everyone. Am I audible?
Yes, sir.
Yeah. Okay, so first of all, I would like to say thanks to the IEEE Reliability Society Hyderabad and to the Paul sir for inviting me for this small presentation. And in fact, it is just a time allocation is very short. In fact, when I was working in the industries for the continuously on the various projects, we have a complete module of reliability and safety, and it will take around 12 to 15 days to complete the whole study or whole analysis that how we can implement the RAMS in the rolling stock. So my total experience is completely based on the rolling stock. I was leading the project with my associate engineers and all, and then I was performing whole implementation from the contract till the demonstration, that the field demonstration. So then I was associated for implementation of reliability and safety in the complete rolling stock. And in my introduction, it is being said that I have done only one project on the in the India, that is Lucknow Metro, and for remaining projects I was involved in the other countries. Yeah. So today, as it is already been explained by the other speakers about the complete overview of reliability and its importance and the safety and its important safety cases by the Rajesh sir, and about the implementation of or importance of the various standards and they are in the complete railway system by the Dr. Ajit. So I will not go to that particular part. I will simply share my few of the experiences while when I was implementing this system, this RAMS in the rolling stock. Then during that, I will try to connect with that V cycle, that in the design how we can do it, and some of the good points which I have taken from those implementation. So we'll move to my next slide. So we know that these are the customer's concerns. There are various concerns from the customer. One, there shall be a system which will transfer the people of goods. That is, we are speaking about the railway system. And whenever in this system, whenever the failures will happen, that will prevent the mission success. Mission success will have its own definition, and this definition, it shall be defined by the customer, that what he is considering as a mission success, whether reaching to the end of the line is a mission success without delay, or it is completely at the end of the day when train will come back on the time, whether it is a mission success. So these are the definition, because based on these definitions, your whole systems design will have an impact, because considering the definition, considering the what is considered as a reliability and what is considered as a safety over here, and how the matrices are involved, based on that, it will have an influence on complete design of a rolling stock. Okay. And then you will see here, there are some failures have the potential service impact, such as the delay. Okay, this is a delay, and then in any case, it is a cost and time to restore. Now here the thing will come is as it was said in the earlier lecture, that we have to have a better maintainability, and we should be able to do our testability analysis. So here your testability and maintainability both will come into the picture, because you should have the system should be maintainable or restored in such a manner so that you will spend minimal time. And in order to do that, you should have a very better testability. Okay, so we'll go next. Here we know that it is taken from the EN 50126, and where the total railway RAMS is dependent on the safety and the availability. It is having the two different way to look into the our requirement. Okay. So one is a safety point of view, another one is the reliability and availability. And this availability and safety both have the different, altogether we can say it depends on the various other factors which are involved. Okay, and then how that particular failure is happening and what are its impact at the system level. Then we can categorize under the safety, or it is only impacting your availability. Okay, so then categories will be different based on the type of failure we will be encountering in the system. Okay. So We'll come to the safety. Just give you a brief overview. It is a freedom from an unacceptable risk, and it is a combination of probability of occurrence of harm and the severity of that. Now, when we look into the complete system design, we have to see that how we can address the different safety related scenarios. Okay. So to address those safety related scenario, it is very, very important that we should have some matrices for the measurement. We should have some matrices for the quantification. Based on that, or with respect to that, we can say that whether the system is safe or system is not safe. Now, this is definition again, it will depends on the society, that what risk is acceptable to the society. Whether when we are saying that, you can see here it is incredible. It means your failure rate is less or equal to 10 to the power minus 9. This is as per the recent standards. It is a guideline given that this is the guide frequency that it is acceptable to the society. Now, it is again based on the country to country. Let's say some countries will say, no, we want exactly further lesser than this. Then they can redefine these complete matrices, okay, and they can put in their contract so that all the suppliers who are the manufacturer, they have to follow this thing, and then their system has to be designed accordingly, that what is acceptable to the society. Okay. And this is a this matrix as a guide matrix, which is taken from the EN 50126. But however, while executing the projects with the different clients, I have gone through the other matrices which are suggested by the countries, different countries, and those were more stringent, or maybe that it is a similar to that. It depends on the their organization and their way of working, and then they have defined it, and we have followed accordingly, and the system was designed considering those matrices. Okay. As it has already been explained in the earlier lectures, that we have this main standards where EN 50126 is for communication, 50128, 50129, EN 50126 RAMS, and these were evolved from the IEC standards. So from the IEC standard, you can see the evolution to the EN standards. Okay, and we also have that yellow book that is the IESM, that is also being followed. Okay, from the UK. So we'll see this REPS process cycle. This is the V cycle. Now, why I'm showing you this complete V cycle? Because it is given in the EN 50126. And EN 50126 says that we have to follow the RAMS management cycle like that. Now, when we will be, because we will see the people who are not following the EN 50126, they are also following the V cycle, because it is based on their own requirements. Okay, and then they have defined the various milestones, and then they are following the similar kind of V cycles. May not be the exact, it is similar kind of V cycles. But what EN will tell us, that when you have to implement the RAMS in a system, then you have to make sure that in this V cycle you are able to address all those requirements, all those guidance which is they have given. Then you have to frame accordingly. You have to put your team in parallel to the design team. Okay, so that during the concept there is a certain requirement which are specified in the EN, and at the same time you have to contact as a RAMS team, because here it will be performed by the completely the RAMS team, which is related to the reliability and safety. But however, other team members which are related to the complete design team, your manufacturing, system validation, other teams will be coming up during this design cycle. And in this cycle, a RAMS team has to interact with them continuously. They have to be in sync with the complete design. They have to continuously monitor the design. They have to give the requirements considering the your reliability and safety to the designer, so that designer will immediately implement in the system. You have to give your requirement for the testability from the reliability point of view. Let's say, for example, some failure has happened. Then you have to ask the right question to the designer, that how let's say maintainer will be able to come to know about the failure, that where the failure has happened. Okay, and then it will talk about the testability. If it is testability is not there, either let's say it is no pop-up is coming on the driver's screen, or there is no signal is going for the maintainer in the maintenance log, then he will not be able to find that where the fault has happened, and then your reliability will come down. And at the same time, we have to analyze that how much time it will take whenever the one particular failure has happened. Then how much time it will take for the maintainer to go to that particular location, whether he has to do repair, replacement, then how much time it is taking, because it will be driven by, all those requirements are driven by your availability requirement. So at initial of the project cycle, you have the requirement for the reliability, you have the requirement for the safety, which is directly coming from the client. If it is coming, if it is not coming, then there is a process you have to follow as per the EN 50126, and then you have to analyze all the possible hazards. You have to create the requirement, and those requirements need to be flown down to the designer, to the other stakeholders which are involved in the whole design cycle. For example, from here the requirement would be going to the let's say electronics engineer, or the design to the mechanical engineer, to the your maintenance manuals. So several requirements will be generated from here, and all those requirements will be addressed either during the design, during the manufacturing, during the verification, validation, and then you have to make sure that all are your requirements which are generated from the reliability and safety point of view, all are addressed in the system. Okay, and therefore here the objective I want to show here is that organizations should have a RAMS team, reliability and safety team, who will be working continuously with that all the design team, whole design team, and the management, top management should have that vision that they want to have this implementation. What will happen? Let's say a RAMS team has given some recommendation that if you want to meet this so and so safety, you have to make this design changes in the your particular design, or you have to specify a particular redundancy, or you have to monitor and track the signal, because whatever the additional requirements are coming, that will cost more in the system. And if let's say top management, they are more about the cost concern, then they will say that okay, do not implement. They don't have the concern about safety and reliability. Definitely no designer will implement this kind of recommendation from the RAMS team. And therefore it should be, whole thing should be driven from the organization's complete policy. What is the policy of the organization? How they want to take this reliability and safety into the complete system. And if let's say there are some of the blockades are happening, whether top management is interested to resolve it, top management is interested to get the solution, if they are ready to put more money into the system to address it. Okay, and then this whole RAMS cycle, because I also seen that in the some of the systems, what the that organization do, they will perform the design analysis complete. They will develop the design based on the functional requirement from the client. Okay, not reliability and safety. And at the end, they will say that okay, now you perform the reliability and safety analysis on my design system. And then if you will perform that, there are several loopholes you will find it out. And going back and redesigning will cost more. And therefore, this standard will guide everybody, or the people who are implementing this standard, that you have to involve from the concept, and then you have to define all your requirement, make sure that it is implemented in the system, and then it is tested, verified, validated, and then when product will go into the field, you should have a better FRACAS system, that is failure reporting analysis and corrective action system, from where you will take the data back, and then if let's say there is again further some changes are required in your design, and if it is critical, then you have to come back and address it. Okay. Now, why it is we have to address the safety? Because there are two concerns. One is a civil liability, that is compensation usually consists in the payment of a sum of money, like contractual liability, tort liability, product liability, and another is manufacturer's criminal liability. Okay, so when let's say the client, they are making it mandatory that you have to follow the EN standards, you have to make sure that your safety needs are addressed into it. It means the supplier for that, he is liable from the civil liability perspective, from the criminal liability perspective, if he is not doing it. If he is not preserving those evidences which during the analysis or during the designs, when they have taken certain decisions, and all those evidences, as Rajesh sir was saying, that there is a safety case is required. Okay, and everything should go into the safety case. That what level of safety analysis has been done, what were the scenarios were involved, and what are the MOPs or evidences are addressed in the various documents. So all those should be addressed over in the safety cases. Okay. Now we'll just give you a glimpse of the safety requirement. So we know that subsystem, they will contribute to reach to an acceptable safety level are managed by the safety requirements. Okay. So the thing is that if we have a certain safety requirements, then it should be able to reach to our acceptable target levels. Okay. Now the question is that if we have a let's say certain safety requirements, okay, so the system is not only driven by your electronic system, because the system consists of electrical, electronics, and all mechanical system. It is an integration of whole system. Okay, and then there is a concept of silicon. So if let's say if certain failures which are leading to your catastrophic event, critical events, then based on that you will decide that what level of requirement you have from the system. Okay. So we'll just try to see one example that when there is it is a combination of your electronic system and there is a combination of mechanical system, then how you can proceed and do the analysis to achieve a particular target. Okay, in terms of the safety integrity levels. Okay. So these are just a basic overview quickly that when we are performing the safety analysis, why again, we'll go to that again, my 8 points, why I'm showing these 8 points to you. Because this safety analysis in the initial of the design phase, it is a major study because it has to be given a lot of time here. Because when we will do the safety analysis, from here we will derive the requirement for the designer to design. From here we will derive the requirement for the maintainer that he has to do certain kind of maintenance after certain periodicity in the maintenance during the maintenance regime. Here also we will propagate the requirement to our verification and validation team from here itself. And from here itself, some of the requirements we will give to the designer from the testability point of view. That this particular requirement, it should be monitored and the particular flag in terms of let's say certain conditions should be pop up on the DDU or to the driver's manual, or it should be given to the driver, or it should be propagated to the other stakeholder if it is required. Okay, so this safety analysis in the initial phase, it is very, very mandatory, and it will, if it is done properly, your major work will be done on the safety from the initial. Okay. So here, it is a main thing is that define the system and method by which the product safety level will be assessed and managed. So you should have the complete system. Okay. Define safety acceptability criteria, that is what is the risk matrix need to be followed, because this risk matrix, if let's say I'm working at the rolling stock level, then this risk matrix I am following at the rolling stock level, same risk matrix I have to propagate to all my suppliers who are supplying to the rolling stock. For example, let's say door supplier, coupler supplier, or traction supplier. So all those suppliers, I will be supplying the same risk matrix so that we will be in sync with each other. Okay. Then identify the hazardous situations. So I have to identify all the hazardous situation, and the same I'm also expecting here that all the suppliers which are supplying to the particular product, let's say rolling stock, they will also follow the same process, same analysis. So when they will be following this one, the complete safety analysis, they will also be generating some of the requirements. They will be generating the requirement again in terms of design. So either their design team has to address it, or they will come back and say that no, my design team will not address it because I'm generating this signal. This signal has to be monitored by the top level system. Then that will become the safety related application condition to the upper system. And in this way, all the suppliers has to interact with the RAMS team, which is working at the system level, and all the requirements which either coming from the lower level, okay, I have to integrate at the train level, and from the train level to the complete system level. So in this way, it should go. And therefore, it is expected that everybody who are involved there, based on the system criticality, based on the level of involvement, they have to perform their analysis considering the EN 50126. Okay. Identify the main causes that are leading to the hazardous situation, define the mitigation measures, and then you have to assess the each hazardous situation again, whether it is a level of safety which is required, whether you are meeting or not. Second. I think it struck my presentation. Let me move to the next. Whether you can see it, my presentation?
Yes, sir. Slide number 10.
Yeah, slide number 10. It is 10. It is just struck.
Sir, you can just try to unshare and share it again.
Yes.
I think you have to remove the pointer. Then you will be. पॉइंटर को डिसेबल कर दीजिए, आगे बढ़ जाएगा.
Yes, 1 second, sir. I will reshare again. Now, can you see it?
Yes, sir.
Hello? Yeah, okay.
Yes, sir.
All right. So we'll move to the next. Yeah. So now, as it was also pointed out by the Rajesh sir, that there are two kind of failures we can have into the system. One is we can say that it is a it is a systematic failure, and then is a non-systematic failure. Okay. So non-systematic failure, that is a random faults. So random faults means here in the non-systematic failure, it is applicable to all the electrical, electronics, programmable electronic systems. Okay, and for that, I will have the failure rate from the various standards, are based on my experience, or based on the testing. Okay, and there are also the systematic failures that can happen into the system. And for that, to address this systematic failure, what we need to do, we need to frame the organization. We have to target the organization. Organization should have a specific process to be followed, so that this systematic error should not happen. There should be process, there should be methods, it has to be followed. Okay. For example, let's say there is a error in your design, manufacturing, operation, okay, like welding procedure, manufacturing process procedures, everything should be addressed. And then only you will be able to address the subsystem failure, like threatening event, that is hazards. So let's say it has also been seen that some of the suppliers or some of the organization, what they do, they will perform simple fault tree analysis. Okay, there is a top event, and I have performed the fault tree analysis, and then we can say that, okay, we are able to meet our target. But that itself is not true in that sense. The thing is that you are able to meet the target, but what about the systematic things? Because it is a, whatever the analysis has been done, it is a theoretical analysis. And then if, let's say, you will make the error into the your systematic procedures, and definitely this will lead to the system failure. And therefore, EN also call for both the things. You should be able to address your quantification, random failures. At the same time, there shall be a process to be followed. Okay, and then based on that process, all the relevant things which is coming, let's say you have to follow the standards for the particular manufacturing process, you have to follow the welding standards, and you have to follow the process parameters as per the given standards. Everything you have to have in your system, in the organization, and then under those specific conditions, you have to do your manufacturing, so that whatever the analysis has been done, or you are demonstrating from the fault tree analysis, it is relevant. Okay. Now, if you go to the just basic study from the safety point of view, we should have initially the project safety plan, and this project safety plan should tell initially that if you are following the processes as per the EN 50126, as per that one, how many deliverables document we need to produce, what are the inputs are required for those deliverables, okay, and what will be the outcome, and then how this outcome is going to be used in the other documentation, and then how it is based on that, how your it is going to impact the design. So you should have the project safety plan. Then using the project safety plan, we have to perform the hazard analysis, as I told you. Okay, and then in the hazard analysis itself, your measure of the part will be covered, because in the PHA, it is a preliminary hazard analysis. Your interface hazard analysis, you have to see from the operational point of view what and all the different hazards are involved. Okay, and then if require, you can further go down and you can take your each and every function, because the organization, when you are developing a particular product, they will be defining that all your functional various function, and then you can see the all the functional hazard analysis as well. And once this hazard analysis has been completed, it will give you a set of the requirement which will address all the safety concerns. And after that, let's say there are certain targets are there, you can demonstrate using the fault tree approaches. Okay. And let's say, for example, when you perform the hazard analysis, you will see that what are different barriers are required, and considering that barrier, if the risk is acceptable, you can go and record in the hazard log, and then you can see the other columns which is required to address during the verification and validation, that you can fill it. If it is not there, you have to go back and you have to think about the additional barriers. And whenever we are thinking about the additional barriers to meet our target levels, definitely it will comes with the cost. Sometimes additional barriers are there, but the designer may not have looked from that perspective. Okay, then you have to go and connect that whatever the barrier is available in the system, connect it with the your safety requirement in such a way so that you are able to meet your target levels. And if it is required, let's say for example, there is already some level of diagnostic is there, and then it is you have to combine with a particular signal which need to be really reported to the driver, and therefore you are able to meet your one of the barrier. Okay, so when RAMS team is sitting with the designer, definitely there are many times you will find that there are some barriers are already there into the system. You have to appropriately use it to make sure that you are able to reach your target levels. Okay, so we'll take one very basic example. For example, let's say we have a derailment. Okay, and we know that whenever the trains are derailed, they will lead to the multiple death or severe injuries. Okay, so now the acceptance criteria here is to demonstrate using the quantitative values. Okay, so we know that derailment always classified as a catastrophic event. Okay, and for the derailment, as per if we follow the guideline from EN 50126, it will come under the incredible events. Okay, and for that we need to have a frequency of 10 to the power minus 9 or lesser than that. And for that, what could be our barriers? We can have the barriers in terms of electrical, electronics, programmable electronics. Okay, all these are the various barriers are could be there. So for let's take one example. This is a scenario. Scenario says that train over speed due to the spurious traction. Okay, so let's say spurious traction is happening. It means there are some failures are happening in your traction system, and we know that failure rate of the traction system. So the thing is that when traction system has failed, when failure rate is very high, so definitely our target is 1e minus 9, that we have to exactly meet the target. And therefore what we need the barriers, additional barriers. So for example, whether this barrier will be provided by the rolling stock itself, or rolling stock cannot provide this barrier, and therefore we have to depend on the other interfaces. For example, let's say signaling. Okay, so for example, let's say in this situation, in this example, rolling stock has considered that train over speed due to traction system he cannot control, for example. Okay, then the requirement has been sent to the signaling system that whenever I am speeding, exceeding a particular speed level beyond a particular allowed threshold, then you have to apply the emergency brake with SIL4. Okay, and when they are doing it, okay, I'm able to meet because I have the initial failure at 1e minus 5 and SIL4 target I'm expecting from the signaling system. And then I know that this scenario can happen anywhere on the system. So it is almost happening of this scenario is 100%. Can exceed that my system failure can happen, and then the time at risk is 100%. I'm able to meet the target here because I'm relying on the signaling system. Now signaling system come back and say me that, or the customer will come back and say that, okay, since you are working at the rolling stock level, don't use this particular barrier from the signaling system. You design your own barrier. Okay, now then again comes my management team will come into the picture because I'm working at the rolling stock level. And I have to think that now what barrier I can give at the rolling stock level that will be at the SIL4. Okay, in that case, again, I have to monitor my speed, rolling stock speed, okay, in such a way so that I will have the speed monitoring with the SIL4. Then again, I have a system which it will trigger the emergency brake when it is exceeding a defined speed with the SIL4 requirement. Okay, and then both the things, to monitor the speed and then to apply the emergency brake, it will bring an additional cost into the rolling stock. Okay, and then at the rolling stock level, I can itself meet the SIL4 target. This is a very basic example I have shown you here, but this is the how the analysis will proceed from the PHA analysis, from the preliminary hazard analysis. Because at when the PHA will be performed, at that time, the system design will be initiating at a very basic level. Okay, so at that time, most of the functions are in the initial maturity level. At that time also, the people who are interacting with the rolling stock are all the interfaces. They are also initial maturity level. And then this agreement should happen between the various functions that who will address this particular scenario. And all those scenarios should be addressed in the initial phase itself, so that they will be, all the designer will be able to put additional money into the system if it is required to meet the safety targets. Okay. And these are some of the calculation which we have to perform based on that whatever the THR requirement we need. Okay. Now going to the another example, that is again this is a safety requirement. Here you can see that there are two systems are involved here, two different kind of system. One, let's say my derailment is happening. Okay, and derailment is happening due to train over speed. Okay, so I can control through the speed control, train traction and all. So here I'm addressing all the electronics related things. Okay, and wherein I have that failure rate of electronic system, I can perform the test. I may have the test data, or maybe that I can do the physics of failure analysis and I can get the data. And I can perform and I can show the target of 1 EMAS line. But what is happening here? At the same time, I can have the mechanical failures. Maybe it could be the Boki hunting, it could be the axle rupture. Okay, and there are other mechanical failures that can also lead to the derailment. Okay, and therefore I have to, if I have to address the scenario of the derailment, I have to address both the scenarios, because derailment, it will not come directly only based on the train over speed. It can come on from the other scenarios as well. Okay, so now how to address the mechanical related issue. And from here, when I'm performing my pH analysis, at that time my requirement should go to the designer for the calculation note to prove that the actual rupture scenario is incredible range, or they have considered the enough margin in terms of the safety factor, or they have performed all the FE analysis. Okay, and all the parameters related to the conditions where the train is supposed to be operated, they have done all the analysis, and they are saying that with the calculation note that this axle rupture scenario will be addressed with the required target level. Now here the target level is very difficult to give, because there is no quantification over here. But however, the other analysis need to be performed. Then after that, there should be the team which is procuring the your material and all. For there shall be specifications shall be given in such a way, okay, so that all the material requirements which are performed, the design analysis which is performed, which is addressed by the sourcing requirement. Then you should have the manufacturing requirement. In the manufacturing, there are various procedures, various codes of practices. What are the standards recommending the very specific procedure to be followed during the manufacturing of the various axles and all that need to be followed. Okay, and after that it will comes on the maintenance requirements. So from that perspective, that maintenance requirement again will go to the maintenance manuals, and wherein the requirements or inspections will be recommended that after certain frequency, and what should be the frequency with which we have to monitor. And in this way, what will happen, the failures which are related to the mechanical assemblies or rotating mechanical assemblies, we will be able to address the derailment scenarios. Okay. Then coming to the failure of an electronic programmable devices, and for that we have to depends on the SIL, okay, safety integrity levels. Maybe that if it is a software is involved, then we have to involve a relevant software like EN 50126 standards, okay, and hardware development according to EN 50129 and all. Okay, so this standard we have to follow, and then we have to make sure that the another part which is involved in the train over speed are addressed. Okay. And then again evidences, all the evidences we have to collect, and then wherever, let's say, collection of evidence will not complete this requirement, because based on those MOPs and evidences, what are their recommendations are there, this recommendation we have to make sure, and it is the responsibility of the RAMS team who is working there, that all those requirements from the maintenance point of view should go into your maintenance manuals, and all the maintainer should be trained. I mean, on all those means. So in that case, RAMS person can go and he can give a basic training to all the maintainers that from the safety point of view, from the reliability point of view, what and all the things you have to do and related to a specific part in the study. And this is how it is tagged into your manuals, and you have to read it like that. And therefore, in this way, that complete your implementation in the design to till maintenance will be completed. Okay, in the similar way, these are the various evidences. Now, just give one brief overview on the reliability analysis as well. Because reliability and safety, we have to deal in the different way. Because when I talk about the safety, what can happen? I can always stop the train. Okay, so whenever let's say there are some failures are happening, I can immediately trigger the emergency brake and we can stop the train. Okay, but however, let's say there is a customer specific requirement where we have to meet so and so reliability targets, and then my job will become more critical here. The thing is that I cannot stop the train every time. Okay, so as a RAMS team, then again we have to do the analysis that whenever the failure is happening, whether we can make sure that train will reach in the safe state, and whether with that safe state we can still able to drive the train to the next station. Because if you are stopping the train in between the two stations, that is inconvenience to the passengers. No one would like to accept that this kind of thing, that you are stopping the train in between the station, you are calling another train to take this train to the next station, or maybe you are detaining the people. It is not at all acceptable scenarios. Okay, so from the reliability point of view, let's say I'm going to detrain maximum. Most of the time I have to make my design in such a way so that detrain, if it is happening, it should happen at the next station. Okay, I should have the bypasses in the system wherein I can still maintain my safety at maybe at lower speed, but the train should be able to reach to the next station, so that this major inconvenience to the passenger shall be avoided. Okay, so if let's say detrain is happening, it should happen in very, very, very rare cases. Okay, so all those analysis, again, it should come into the initial design phase itself. And as the design will progress, your designer will give the complete architecture of the system. Then you have to perform your failure mode, effect, and criticality analysis for each and every component. Each and every component has to be monitored, or we can say analyzed, whether it is going to fail, within what additional barrier you have, and where, let's say, this component has failed, then what you have in the system to identify that this particular component has failed. Because there itself you are also addressing your testability analysis, you are also giving the signals to the maintainer, so that maintainer will be able to identify in a very shortest possible time that where is the failure has happened. And if, let's say, there certain failures are happened, do you really want to address it immediately by the driver if driver is there? If no driver is there, means it is kind of depends on the system. Let's say it's an automatic train, in that case no driver, then you really want to have the redundancy system, so that once it is failed, it will switch to the redundancy system. Or let's say some signals you want to have to go to the driver, so that driver can take that particular bypasses and he can drive the train to the next station or to the end of the station. So all those analysis will come into the you have to perform from the reliability point of view. But however, this reliability analysis will be definitely influenced by your safety analysis, because you are also making the decisions related by addressing the safety over there. And at the end, let's say you are meeting all the safety requirements, and you are going in the more optimistic way, and definitely you will end up on lower reliability on this side. And therefore, it become very challenging job to address both the things in hand over there. Okay, so initially, there is a tender phase will be there, and here in this case, what will happen in the systems where I worked in the other countries, there is a specific targets are given by the customers, okay, to meet the reliability targets. And those targets, I have done the analysis, and then based on the target, that how I can implement into the system, that analysis has been performed. Okay, and in certain cases, the targets are, let's say, it's there is no target given by the supplier customer, but still, it again depends on the organization's policy. It is depends on the top management how they want to take the system to forward. Okay, so because it is also depends on the reputation of a particular supplier. Let's say the well-known supplier is there, and if, let's say, there is no target coming from the customer, and if he has designed system in such a way which is not at all reliable, which is having a very low availability for it, so then it is going to have an impact on the next sale in the same country or maybe in another country. And therefore, again, this again should be driven from the top management, that in case of no requirement, how to take the system forward. Okay, at least some basic organization structure should be there. And then in that one, irrespective whether customer is asking or not, by default, with the optimal cost, you have to implement what is possible into the system so that they are be equally competent in the next tenders and all. Okay. And this is the EN 50126. If you will see that they have given this complete one system. Again, I'm coming in this complete chart, because here I have observed one thing. Whatever you will do into your during the allocation phase, you will implement into the system, and you have done your verification, validation, and then you will put into the train onto the operation. But what is more important is that how you are monitoring the things from the or how the system's demonstration phase is being addressed. Okay, because here you have seen that during the design you are able to meet the targets and it's well and good. But however, when you go to demonstration, what kind of system you are implementing there? Because there again, that some engineers from the reliability or safety point of view, he should be deployed over there. There should be a proper fracas system which is collecting the data from the field. Okay, this data could be the failure time data. This data could be in terms of continuous data which is a system is generating based on its health parameter. It again depends on that what kind of system we have implemented from the diagnostic point of view during the design, and then this data should be continuously monitored. Then based on that data, you have to let's say reschedule your maintenance, or you have to do your early maintenance, or there are some of the critical failures which are not at all happened in other system and which is happening in that environment, in that country, or at that location. Then you have to immediately address those failures from the design point of view, from the maintenance point of view. And therefore this demonstration phase again become very, very critical, and it require specific reliability engineers, RAMS engineers to work with the system when trains are in the operation. Okay. Then this is one example I have given, because I find this approach as a very, very practical and very good approach when I was doing the analysis, or I was allocating the targets to the various subsystems when I got the target from the client. Okay, so what could be the best way it could be possible? That since we have the functional breakdown structure of a complete system, so you just break down that particular, write it down and do the functional wise analysis. Okay, so you take a one particular function, do its analysis. Let's say this particular function will fail. What will happen at the train level? Okay, so whether it is a rescue, or it could be the delay greater than 5 minutes, no delay at all. Okay, and what will happen? Okay, so for example, let's say it is a rescue. It means you are also taking the scenario from both the perspective. Let's say either it could be the rescue due to safety scenarios, because this function is failed, whether it is a relative safety event, or it is a rescue because you cannot drive the train further. Okay, so then accordingly we can do this analysis. Okay, so we can categorize it, and let's say for example what the next level we can do. Okay, so let's say this is a pantograph management. Okay, so let's say lowering of all the pantograph spuriously. Let's say your all pantograph will spuriously lower down. Then what can happen? You will be end up in the rescue. Okay, then I have to analyze this. Okay, so whether I have how many pantographs I have on the system. Okay, and what is the probability of happening this failure rate of happening this particular event. And then I can go down to this spurious of lowering of Pento 1, Pento 2, Pento 3, and then I can go further down into the Pento 1, and I can write down further equation, and I will see its overall target values, whether what is the failure rate. If this failure rate is, let's say it's the way within that my acceptable level, okay, and it means it is showing that happening of this event can happen, let's say over the period of 10 years or 15 years. Okay, then it will, let's say my target, it is reachable to the target, I can go ahead. Otherwise I have to ask the management, no, we need another further one more pantograph, or we need the combination, or we have to separate the circuit in such a way so that common event should not happen. So all those analysis should come from the reliability analysis when I will be doing here. Okay, and it will have the direct impact on the design. So this is all just try to give you that glimpse of that reliability and safety, and then how to means we can do it, and it is a require. In conclusion, if I will say, it will require a dedicated team. It will require a dedicated mindset of the complete organization. It will require approach from the top management. It will require the cost at all. Okay. So thank you. Thank you. If you have any question, can take the question here. Yeah. Thank you.
Thank you, sir. If any question, please go ahead and ask.
Good afternoon, sir.
Good afternoon.
My question is, in the V diagram, RAMS management process V cycle. I'm sorry, V cycle. Actually, in our application, we have stage-wise design reviews, sir. Do you have similar concept in the?
I mean, you are talking about the which system in it is a aerospace system or it is a railway system only?
It is aerospace system, sir.
Yes,
Aerospace system. So we have a design review. So
I agree. I agree. Means it is a similar. If you will I have shown you that V cycle. Okay. In the V cycle, there are this again. If rolling means EN 50126 say that okay, you have to review it. You have to review it this way. Various phases. But yes, there are the design cycles. It depends on the organization to organization. So some of the good organizations will say, okay, so they have implemented the design reviews, and in the design reviews, considering that what is the requirement from the EN 50126, okay, what is the internal obligations from the company. So they have defined a complete checklist, okay, and during that particular design review, the quality team will be involved, and then all the checkpoints will be checked, and MOPs will be presented that this analysis is done. If let's say certain things is open, whether it is open from the supplier side, whether it is open internally, or whether there is a design deficiency, and then that should be highlighted immediately at that particular design review itself, so that top management can take the decision how to implement and how to address it at this particular phase of the maturity of the design. So yes, it is required.
Yes, yeah. Second point is, sir, this design review and I'll get back, sir. I wrote down somewhere. So
I'm Kashyap. I have a query. I'm DST Tikas. We are implementing a Kavach system in South Central Railway as a field unit.
Yes, yes.
I have a very basic doubt. What is the legal validity of this ISA and all this RAMS process? Is there some specific act for railway? There is some railway act for India.
Right.
In the Indian scenario, what is the legal validity for this? Have there been any disputes in your experience, legal disputes between the firm, the client, the ISA?
Maybe that, the thing is that I understood your question. Whether this legal dispute happened or not, maybe that this Paul sir is there, and then other very experienced people we have over here. But based on my experience, if I will say what exactly EN 50126 tells. Okay, so EN 50126 tells that you have to follow a specific process. If you are following the specific process, you will be able to address all your safety requirements and the reliability requirements. You will be able to implement in the system. You will be able to make sure that it is preserved in the system by the maintenance. Okay. Now the thing is that whether following a systematic approach is correct or not, it has to be decided by the who is giving the tender to you. What is the requirement in that particular country? How the organizations are working. For example, let's say if you will say that I got a contract from the Australian authority, okay, that we have to design the Perth metro systems. So for the Perth metro system, because it is legal guidelines from their own country, that supplier has to follow this standard. Supplier also has to follow their own internal guidelines, and based on both of these things, whatever is stringent, that has to be implemented. Okay, now they are very clear in that one. Let's say tomorrow certain accident is happening, okay, and someone is going to the court and making that manufacturer responsible. Then in that case, manufacturer should be able to produce all sort of evidences that whatever the requirement was given from the legal perspective from that country, okay, and we have taken the decision accordingly. This is the proof we have. We are still meeting the target which are given, and whatever the scenarios happened, It is beyond that one. Okay. So all sort of evidences, MOPs you have to produce, so that what will happen? Your criminal liability will go away from there. But however, maybe that I would like to ask from the other members if they have certain, this kind of experience in the wherein any accident was challenged and in the courts, and then certain specific rules came out from the RDSO or anybody. Maybe I'm not much aware on that.
No, I
think-
request if
yeah.
Rajesh is available, then if he can answer.
Right,
Yeah.
right.
Yeah, good afternoon. Yeah, as per say ki once it is in a contract, so as per contract application contracts rules are there. They are enforceable in a court of law. Yeah. So if it is a condition in contract, it is definitely there. Okay. But see, all other things, at what extent things are going on, and most of the contract doesn't go to that extent, and our client even don't go to the extent. Many things is that over if it is a guidelines are there. If say RDSO once given some guidelines, then they become guideline for client metros etc. If CRS asks certain things, then it become guideline. Because one thing is that contractor with a designer or just supplier, his money is there. They are in a business. Okay, they give the information to the extent they are comfortable. I have seen when we go in probe them, even in Chinese firms, we have probed them and we find the certificate of PhD controller. Okay, up to that level. So they have many informations. When we go and asking sort of question, they will give it. Like even in Tika's case also, all supplier, because ultimately their product has to extend to the market, and they will not take any risk as far as their area is concerned. Yes, they go for cost cutting or corner cutting only when they say कि yes, client को इतना ही बता दो भी चल जाएगा या वो ज़्यादा नहीं पूछेगा. Sometimes what happen, we don't give them the comfort, कि to be honest, let them come. Because होता ही है कि यदि ज़्यादा बता दिया तो फिर आप उसके पीछे पड़ जाओगे, तो वो बताता नहीं है. So there are many area, gray area, we have to give confidence. We have to give. Say they have also trust, because बहुत से लोगों को लेता है यार रेलवे वाला मानता क्यों नहीं है, ये हम इतना सिंपल सी चीज, और रेलवे वाला क्यों मानेगा? Because he has his own responsibility where he has to comply certain things. Okay, ऑडिट विजिलेंस और तमाम तरह की चीजें, वो क्यों पड़ेगा आपके काम के लिए? Then another thing is कि when you become transparent to them, sometimes you have to help them also. Yes, this is the thing how you can implement. So I find many of the things we can get it done, which are say this arbitration and legal thing will come when we are not honest to our own thing. People become honest to their things. Your contract is one paper, but once we have confidence and trust with our partner, बहुत सी चीज वो करता है, ऐसा नहीं है. और बहुत सी चीज आप भी उसको, ठीक है आप ये नहीं दे रहे हो, आपकी बजाय ये दे दो, इसकी जगह ये लिख लो. इफ यू आर नॉट गिविंग से रिलायबिलिटी क्रिटिकल आइटम लिस्ट, अच्छा ठीक है आप रिलायबिलिटी रिपोर्ट का पार्ट बना के दे दो. So somewhere, because you once you have given, यही बहुत है, ये this is a systematic failure. Our tenders document become a systematic failure where we don't give the clear specification or guidelines etc. और कई जगह conflicting चीज होती है. वो चीज यदि धीरे धीरे हट जाती है तो फिर then you will find कि सामने वाले भी समझता है. अदरवाइज होता क्या है कि कॉन्ट्रैक्टर दे आर आल्सो इन कंपटीशन. बहुत सी चीज आती है, ये बहुत हिट ऑफ देते हैं, हमको यही बताया कि ठीक है आप डिजाइनर नॉट एग्री, वी आर आल्सो नॉट एग्री कि ये नहीं होना चाहिए. बट उनका जो मार्केटिंग वाला, जो सेलिंग वाला, जो बिजनेस टीम आती है, उनको किसी भी हालत में वो टेंडर लेना रहता है. तो वो किसी भी हालत में, हाँ सब ये भी हो जाएगा, वो भी हो जाएगा, सब हो जाएगा, वो सब में हाँ कर देता है, क्योंकि उनको लेना है. जब एग्जीक्यूशन की आती है तब पता लगा साहब ये तो हो नहीं सकता है, ये तो हो नहीं सकता है, ये तो हो नहीं सकता है. देन ठीक है, then we also see what technically and seeing to the clients you can say their interest, and we can go that way. होता है. हमारे टेंडर बड़े लूज एंड वन साइडेड. आई सीन व्हेन आई वाज इन DUV, they were not agreeing कि where the DMRC CST was the accepting arbitration. क्योंकि वो कैसे वो arbitration बैठ सकता है जिसने मेरे कॉन्ट्रैक्ट साइन किया. यस, बट अभी से कि बहुत सी चीज ऑपरेशनल नहीं रहती है कॉन्ट्रैक्ट में. So it comes a test, and we as our contract has to go in a long way, and we have to comply with it.
May I request Dr. Ajit also to throw some light on this?
take.
Okay, thank you, sir. Thank you. See, this is a very big topic. So first of all, Rajesh sir has mentioned, Dr. Jalal mentioned, the where the gap in our system in any project in India. I have seen in many projects. I'm not very confident, but I have seen there is no requirement management guideline. What is happening here? Suppose you have contract, people are writing requirement. There is no tools properly, like Comply Pro, like DOORS. So what has happened? There is a gap, and that's why contractor and other party are playing. So if you have requirement management proper Excel sheet, how many requirements, how many RAMS requirement, how many safety requirement, and how the requirement has been, verified, validated, accepted. So since all the requirements are documented black and white, and people are playing here and there, so that is the one gap. We should, in Indian system, we have to specifically decide on requirement manager, where he captures all the requirements, design requirement, BNB requirement, safety requirement, and then every department will make sure this requirement I agree, and some kind of agreement will happen. And that is the first step of the corrective action. Then after what sir told, there is arbitration, all this is secondary things. Okay, the first thing, requirement is not properly segregated. So this is the I learned from other countries where they have dedicated requirement management team, and this is the independent team from interest requirement, EMC requirement, all are there. So that is the where, and because it's part of system assurance, the first starting point is the requirement management. Then only we can go and implement as per this. Okay. And secondly, that the legal along this thing. See, it depends upon the country maturity. I just mentioned we are now slowly adopting. When I started my RAMS career, it's 10 years back, properly RAMS. So it was not quite popular. Only a few metro are working. But nowadays, almost every system, even DFCC, Indian Railway also have RAMS requirement, RAMS guidelines. So we are progressively, improving in this area, and still gap is there. So until unless this subject is get appreciation from the government bodies, regulatory body authorities, I think it is difficult to achieve the quite, compared with other systems. So, and last thing, RDSO has given many kind of ISA in their panel. There is a product ISA, there is a product ISA, and through this kind of implement of the ISA, I think we can already additional layer of safety assurance. Even though we are doing good hygienic practices in our system design, but in spite of that, we are also having some kind of independent bodies who can endorse our design or client design. So I think we are still progressing, and still we have to go a lot. And thank you so much.
Yes, now just I want to give a straight answer based upon this to this query. In fact,
if we go to the European countries, there is a health and safety regulation, and that is applicable to all kind of systems. Even non-compliance of any of these standards are dealt with the health and safety. If anybody is injured, if anybody is, even person has got, his fingers has got stuck in the door of the metro, and he is claim, he is going to be dealt in that. So unfortunately, that kind of regulation is missing in our country. So this is the one gap. Second thing is that whatever recourse we are having as of now, as far our tender obligations is concerned, rightly Rajesh has pointed out, Dr. Ajit has pointed out, that our tender documents, that is the only document which is defining the contract between the client and the supplier, means railway and the contract. Unless you mentioned all these requirements specifically, unambiguously in the contract tender document, you cannot enforce that one. And what is the law which is going to enforce this contract condition? That is a contract law, a contract act of the law. There is no other way out of any redressal. So ultimately, for any non-compliance of the contract condition, you have to go to the court under the contract law only. So that is the only law available as on date. So there is a point what our speakers, eminent speakers has already emphasized, that we have to learn to frame our requirement specifications and write it down specifically in our tender document, because that is the only document and the court is the only recourse. There is no other recourse. And the second layer is of course, IRCBC, Criminal Procedure Code. That is the only thing. If any death has happened, then it's the only thing. There is no other way out right now. We are in job in progress, basically, work in progress, and we have to do. In fact, in 2015, I only wrote a paper on the two aspects, quality and safety assurance process, as per the EN standards and what we are following in the Indian Railways. That I presented in Aspect 2015 in IRC seminar. That paper is available. That gives quite a substantial idea. In fact, I would like to present that paper in subsequent sessions so that at least a good understanding is developed.
Good.
Right. Thank you.
Thank you, sir. Any further questions?
Yeah, my question is to all of the speakers, if anyone can
Okay.
reply. We are talking about Mr. Rajesh has given us a fair good idea about what goes in the safety case. And as we understood that a generic application is basically a culmination of the generic product and the specific application case. There has been a lot of talk about the testability also. Now, the only thing I wanted to ask is now as railways we are hiring an ISA who will do the scrutiny of the safety case and will certify. The onus lies on which party to ensure that all the test scenarios which are required for the system to work safely have been covered.
Okay. Thank you for this, sir.
Is it the ISA or
Yeah.
we are
Nah,
solely dependent
yeah.
on the
How
VNV
you
team
will
of
see
that
that? Yeah.
OEM?
Correct. Yeah. Let me answer it the other way. Say, what is our approach? It is a shifting of responsibility or getting the product done. Okay. So just that what you have rightly said, it is whose responsibility. But most of the thing this has come कि साहब हमने ऐसा रख लिया अब उसकी जिम्मेदारी है. अब ऐसा सही देख रहा है इसकी किसकी जिम्मेदारी है? ऐसा कहाँ तक देखा? Because say I seen one of the in TUV when I was there and दुबई में एक ट्राम का एक्सीडेंट हो गया और मैं अभी नया नया ज्वाइन किया था. उन्होंने कहा था कि 2 दिन में आया, उनका यहाँ का एरिया मैनेजर था मुझसे और मैंने कहा यार ये एक्सीडेंट हो गया ये तो है, तो कहा कि हाँ ये मुझे भी ये नहीं है, ही गॉट इट. फिर उसने तुरंत हाफ एन आवर में वो डॉक्यूमेंट देखा कि साहब हमने जो कंडीशन दी थी सेफ्टी सर्टिफिकेट में उसमें जो जो थी ये कंडीशन उन्होंने फुलफिल नहीं की. ओके, नाउ इट इज द रिस्पॉन्सिबिलिटी ऑफ क्लाइंट. राइट, ठीक है. तो जब आपको ऐसा जो सर्टिफिकेट देता है उसमें बहुत सी कंडीशन रहती है, साहब आप ये करना, ये करना, आपने वो कंडीशन नहीं की तो आपकी जिम्मेदारी है ना. यही होता है, यही हो रहा है इंडिया में कि बहुत सी वो सिस्टम रिक्वायरमेंट एप्लीकेशन कंडीशन बताता नहीं है. पहली बात तो जो मेन प्रोडक्ट वाला बताता नहीं है, आपको कैसा सर्टिफिकेट दे दिया हो गया काम, दैट इज नॉट सफिशिएंट. आपको वो भी इसका सेफ्टी केस भी लेना है या नहीं, वो कहे बहुत से हमारे ऐसे साहब ये हमारा कॉन्फिडेंशियल डॉक्यूमेंट, तो हमने कहा ठीक है थर्ड पार्टी आपका ऐसा है वो देखेगा, वो हमको सर्टिफिकेट देगा कि ये उसमें है कि नहीं. ठीक है, तो हमने उससे लिखवाया कि साहब ये, फिर अच्छा सेफ्टी रिलेटेड कंडीशन ये है. अब उसने जो कंडीशन दी हमने कॉन्ट्रैक्टर से पूछा भैया ये कंडीशन है, ये कंडीशन आपने फुलफिल की है नहीं की. उसने कहा साहब ये मेरी नहीं है. फिर मैंने कहा आपका कैसा सिल है, उसने कराया वो. तो उसके बाद क्योंकि हमको ये भी है कि हमारे ऐसा जो 2015 तक में थे बहुत टफ थे. व्हेन आई वाज इन चेन्नई और मुझे जो डॉक्यूमेंट दिल्ली मेट्रो और नागपुर मेट्रो है वो बहुत ही मतलब डिटेल में ज़्यादा पूछ रहे थे. पर उसके बाद उनका ये हो गया कि साहब ऐसा है कि इनसे ज़्यादा पूछो तो हमारा बिल रोक देता है ना, और हमको काम नहीं निकालने देता है. तो इनको ऐसे ही बताओ कि और हमारा ऑडिटर के प्रति भी इतना सम्मान रहता है कि साहब इसने लिख दिया तो भगवान हो गया ये, है ना. कभी ऑडिटर को पूछते नहीं है कि साहब ये ऑडिटर ये हुआ कैसा है, तुम बताओ तुम ये कंक्लूजन में कैसे आए. हाँ, कि उसकी भी जो भी कंडीशन वो कंक्लूजन देता है उसकी, इसीलिए उसकी जो आप असेसमेंट रिपोर्ट बनाते हो उसके असेसमेंट रिपोर्ट की बेसिस होना चाहिए. अभी सिर्फ ये कहते कि मेरा सेल हो गया कि ये फाल्ट्री एनालिसिस ने ला दिया है, दैट इज नॉट सफिशिएंट. ये आपका स्टैंडर्ड है, ये चीज होनी चाहिए, ये आपने देखा है कि नहीं. यदि देखा है तो उस डॉक्यूमेंट के मुझे रेफरेंस दीजिए, है ना, कि साहब ये वाला था, इसमें मैंने सर्टिफिकेट ये बेसलाइन का देखा और सर्टिफिकेट नंबर ये वेदर इट इज वैलिड और नॉट. तो आपको ये भी देखना है कि देखिए पूरे सिस्टम में एवरी स्टेक होल्डर इज देयर सम रिस्पॉन्सिबिलिटी, है ना. हमने ऐसा को या थर्ड पार्टी को, चाहे वो आपके कॉन्ट्रैक्टर ने रखा हो जो अपने प्रोडक्ट के लिए रख रहा है, उसकी भी एक रिस्पॉन्सिबिलिटी है. उसको नहीं देगा तो उसको पैसा नहीं देगा, तो वो भी उसी ढंग से कंप्लाई करता है कि साहब इतना दे दिया। अब वो जब सर्टिफिकेट देता है तो आपको उसको बेसलाइन जो सर्टिफिकेट देता है उसमें देखना होगा कि उसने सेफ्टी केस या सेफ्टी रिपोर्ट का क्या रेफरेंस दिया। वो सर्टेन पेरा सो एंड सो वहाँ सेफ्टी रिलेटेड एप्लीकेशन इज गिवन। आप देखिए नीचे उसमें वैलिडिटी एंड दिस इज नॉट द स्टैंड अलोन पेपर, सर्टिफिकेट इज नॉट, इट इज बेस्ड ऑन सर्टेन सेफ्टी केस असेसमेंट रिपोर्ट। वहां से आपको पता पड़ेगा कि उस सिस्टम का आर्किटेक्चर क्या है। सपोज आपको जो सबमिट कर रहा है वो सिस्टम आर्किटेक्चर डिफरेंट हो गया तो सेफ्टी केस का कोई मतलब नहीं है, तो आपको उसका वर्जन देखना पड़ेगा। अभी हमको कुछ दे देगा साहब मेरा ये एटीएस का ये साहब ये वाला वर्जन है। अब मुझे जब सर्टिफिकेट में वर्जन नहीं मिलेगा तो मैंने कहा नहीं, आप वर्जन जो पहले 1.1 दे रहे थे अभी आप सप्लाई 1.5 में दे रहे हो, तो ये डिफरेंस क्यों आया है? तो मुझे आपके आयसा से लिख के देना है कि विद द चेंज ऑफ दिस वर्जन देयर इज नो विशिएशन ऑन माय सेफ्टी लेवल अचीवमेंट। तो ये आपको उससे पूछना पड़ेगा भैया ये चेंज हुआ तो ये हुआ। देखिए ये सभी लोग करता है, सभी लोग मतलब अपने यहाँ बोलते हैं ना एक शाणा है, तो वो सभी लोग करता है, सब बहुत अच्छा बताता है, उसी से लिखवा कि साहब ये मैंने अच्छा किया, तो आपकी पहले तो स्कैन बच जाएगी। दूसरा है कि वो सही है कि नहीं ये भी हमारी जिम्मेदारी, क्योंकि देखिए अल्टीमेटली रेलवे एक ऐसा है ना वो अपनी जिम्मेदारी से बच नहीं सकती है। मैं दुबई में था तब उन्होंने एक चीज बताया था कि साहब वहाँ 12 साल से बड़ा बच्चे छोटे बच्चे यदि वो इस मतलब देरी नो उनके साथ एक अकम्पनीमेंट होना चाहिए, कोई साथ में होना चाहिए। तो मैंने कहा साहब 12 साल के ये मेरे साथ में बैठे हुए बच्चे वहाँ ट्रेन में जा रहे हैं, ये तो स्कूल गोवर हैं, और यदि ये मर गया तो जिम्मेदारी गवर्नमेंट की होगी कि नहीं होगी? आप रूल से नहीं बच सकते हो। आपको आपकी देखिए आपका इथिक्स विल कम बिफोर द रूल्स। ये रूल में ठीक है आपने किसी को जिम्मेदार करता है, बट यू हैव टू टेक केयर इन योर डिजाइन की कौन सी चीज आप इम्प्लीमेंट कर सकते हो, है ना? तो जब आप उनसे अपने आईएसएस कराने जाओगे तब भी उससे 10 क्वेश्चन कि आपने ये रिपोर्ट दिया इसमें ये चीज है कि नहीं। सबसे बड़ा है कि 17065 अनफॉर्चुनेटली आरडीएसओ भी वो कोई से रिपोर्ट नहीं मारता मेट्रो से कि आपके कौन कौन से ऐसा ने क्या किया गया, क्योंकि उनको ये भी नहीं पता है कि ऐसा ये 17065 क्यों दिया है, कि उसका ऑर्गेनाइजेशन क्यों चेंज नहीं कर सकता है, बिकॉज देर इज इंडिपेंडेंस ऑफ दिस वन। एक बंदा यहाँ काम कर रहा है दूसरा नहीं कर सकता, देर आर 2 years है ना। और एक बार जब वो ले लेता है जिस क्योंकि देर इज अ कॉम्पिटिशन, तो जिस सीवी के बेस पे लिया है, आई एम सीइंग मेरे बहुत से सीवी चल रहे हैं इधर उधर, मुझे बाद में पता लगता है कि सब ये उसने ले लिया है, बट दिस इज नॉट इथिकल फॉर देयर पार्ट। बिकॉज पहली चीज उनको देखना चाहिए कि जिसका उसने सीवी दिया वो रहे बंदा, उसकी प्रोसेसेस रहे, उसके रेगुलर आपको जो आपने जो दिए हैं उसको फिर उसके साथ हर चीज चाहे कॉन्ट्रैक्टर ऐसा हो या दूसरा, उसको आपको कमर्शियल के साथ जोड़ो कि साहब ये मेरे को पेमेंट होगा तो ये दूंगा, ये नहीं होगा तो। कई बार आपने उसको फाइनल चीज दे दी, बीच में बहुत सी पेमेंट नहीं दी, तो वो नहीं करता है। यू हैव टू लिंक। दूसरा है कि जब आप जैसे अपन ने जब मेरा ये अनुभव था जब भुवनेश्वर में था वगैरह, तो आपने एक चेकलिस्ट दे दी भैया ये चीज भर के आएगा कॉन्ट्रैक्टर कि मैंने ये काम कर लिया, मेरा एसएससी उसको देख लेगा कि हाँ इतना काम हो गया। 5-10% के इधर उधर हो सकता है, तो उनके बीच में लड़ाई नहीं होगी, ठीक है, कि हाँ जो लिख के दे रहा है वो अप्रूव कर रहा है तो आपको पेमेंट में, बिकॉज अल्टीमेटली कॉन्ट्रैक्टर पेमेंट पे वो करेगा, आपका काम इधर उधर करने के बाद भी हिज प्रायोरिटी इज दिस वन, और आपका काम है काम लेना। तो जब आप किसी को रिस्पॉन्सिबिलिटी देते हो तो बी केयरफुल कि उसका काम क्या है, ऐसा ये कौन कौन सी चीज उसको करनी ही चाहिए, क्योंकि वो आप कॉन्ट्रैक्ट में जब देखते हो ना बहुत से इधर उधर का कॉपी पेस्ट करके सब दे दिया उसने, ये करना वो करना वो करना, है जब करने जाते अब लिफ्ट में एस्केलेटर में यदि कोई ने दे दिया है, अब ये लिफ्ट एंड एस्केलेटर ऐसी चीज है कि स्टेट गवर्नमेंट का भी बहुत स्टेक रहता है ना। आप NFPA 130 वगैरह ले लो, पर स्टेट गवर्नमेंट का इनिशियल सर्टिफिकेट बाद के सर्टिफिकेट ये सब रहता है। अब आप पूरे मेट्रो का यदि कोई सर्टिफिकेट दे रहा है तो आपको ये भी देखना पड़ता है कि वहाँ पे फायर वालों के कितने सर्टिफिकेट रहते हैं, तो यू हैव टू आस्क देम। तो ये चीज उनसे ही कॉन्सल्ट करते हैं कि भाई अच्छा ठीक है आपने प्रोडक्ट बनाया, आपने क्या चीज आपने रिक्वायरमेंट क्या ली, या हमने दी फंक्शनल रिक्वायरमेंट जो दी वो क्या थी, उसमें भी वो बता सकता है कि सब ये चीज की ये है, उसने अपने टेंडर के समय या देते समय ये बात उठाई है कि नहीं। यदि उठा लिए तो फिर उसको ट्रेस करो आपके डॉक्यूमेंट में, जो डिलीवरेबल है उससे डॉक्यूमेंट के साथ मैच करते जाओ, देन उसको एक बार डिलीवरेबल हो गए, ऐसा नहीं हो कि कुछ डिलीवरेबल आपके सिर्फ फाइनेंशियल या कुछ में है ही नहीं तो वो देगा नहीं, है ना। फिर आपको क्योंकि आपको कॉन्ट्रैक्ट कंप्लाई कराना है तो जिम्मेदारी आपकी हो जी, और वो दे नहीं रहा है, तो देयर हैज टू बी सम बैलेंस आर यू से वेरी स्पेसिफिक थिंग कि मेरे को ये आपको देना है। तो सर्टिफिकेट में ये ध्यान रखिए, जो भी सर्टिफिकेट दे रहा है देयर नॉट एक तो कॉन्फ्लिक्ट नहीं हो। आप बेस लाइन सर्टिफिकेट यदि मान लो एक आपका मान लो एटकिंस ने कोई सर्टिफिकेट दे दिया है ना, अब एटकिंस वहाँ पे आपके प्रोजेक्ट लेवल पे नहीं हो सकता। देर इसीलिए देखिए ईजीस और कुछ कंपनी अब ऐसा का वर्क ज़्यादा नहीं करती इंडिया, बिकॉज दे आर मोस्टली ऑन जीसी, है ना, क्योंकि देर इज अ कॉन्फ्लिक्ट। ऐसा नहीं है कि ये कंपनियां जानती थी, वो सब जानती है कि क्या करना चाहिए क्या नहीं करना। इफ वी आर कंप्लायंट तो दे विल, आरडीएसओ में वही जाके बना के आते, सर्टिफिकेट दे दिया ये दे दिया, बट वेयर दैट सर्टिफिकेट उसका कंटेंट क्या है ये जरूरी हो जाता है।
Any other question?
It's not a question asking about, he was asking for legal route. In our application, in our where I work, what we do is that we have like your contract, it is equivalent to RFP, request for proposal. In that we have the commercial part is there, that is taken care by the project, and RAMS part is taken care by the QA. In that we tell what type of quality grade of components to be used. And like madam, she has told the test, what is the test matrix, what are the test levels to be done, what are the review boards to be formed. For example, non-conformance review board during the product realization, any deviation in the specification, any failures, non-conformance board, they will do it. So we have, we put everything. The QA puts the QA chapter in the RFP, and then QA vets the document demand, then it goes to the stores, and in the demand also we say that these are all the list of deliverables, and we also mention that point by point compliance from the vendor, that these are the things, these are the documents we are requesting you to provide during PDR, during CDR, during mission readiness review, so that the vendor is aware before he quotes that these are all the costing he can do accordingly, and then give it to, so that there's a smooth transition in the product realization. Even if components are there, we ask for the COC from the OEM. What they do is that traders, the counterfeit component issue is there, we are also facing. But we ask for OEM, whoever is manufacturing in US or your COC, we want. And we want the date code, we want the lot code. And we what is the type of quality grade you are giving, whether it's a space grade or the mill grade, or we don't use commercial or industrial, we use the mill grade and space grade. So these things we put clearly, and there is a binding for him to the, when the RFP goes to the vendor, industry partner, there is a binding, point by point compliance. Then even during the, when he's delivering the product, it again we check, QA, as a QA, we check whether the demand copy, RNQA chapter we are making, so we have the list of documents to be done. When the product has come, we check whether in the CD, either in the soft copy or hard copy, the documents, we tick it, we check it, whether as per the terms of reference he has given or not. And anywhere, see, one thing is that when we are asking some new things from industry point of view, also we need to think. Sometimes we need to guide them, handhold them, and tell them. Some we are saying you do FMICA, FDA, reliability analysis, parts rating analysis, hardware software interaction analysis, thermal analysis, mechanical analysis. So sometimes if a new vendor is there, he may not be familiar. So we need to enlighten them like that. So that way there is a binding. That's how we work. And one question, sir, I wanted, that's what, whether EN standard mentions any non-conformance review boards and all, Rajesh Patel, sir, or...
Say non-conformist, they say mostly they for the quality where they already define their audit. Okay, so in audit plan already given what are to be seen. Okay, what are the point to be there, and apart from that they give which stage you are giving the audit. Say it is only design stage, then what is the organization, what is the things where their teams are there, etc. Their change, etc. There. When we go for manufacturing audit, the things come. Your calibration certificate, whatever tool you are using, whether they are not, or whether they are accredited or not. Sometimes you file their 70025, the lab, etc. Some are testings are there. They have the process. Now government has, after this Jaldhal Har Ghar Jal Yojana, they have come up with a quite good thing. You have to use those things also. What are the things? Because your audit plan have many of the things, including the interview of the designer, change controller, document, even document controller also, because there is a very clear traceability requirement in case of safety case. Okay, so there were thousands of documents. It is very difficult which version is there or which things are there. So that has to be taken care of. So there comes some of the, because this is one of the thing in safety case we ask, yes, you tell me how many audits, वो तो सब ठीक है, 30 सा मांगा है, so whether there is NC, then we required who is the auditor. We want from auditor there is no NC, say there must be third party, so they give certificate and they give it.
Just to add on this, see,
Sir.
just to add on the Rajesh sir, see, what madam told about all the procurement, everything is properly evidenced in our safety case. Basically, in safety, there are 3 chapters. So 3 chapters only. Chapter 1, the quality management report, which includes how all systematic fault has been addressed with respect to quality, with respect to human error, everything. And second chapter, safety management report, okay, how you safety are going to manage, okay. And third is the how to manage random failure. So all the activities what we are doing in the railways, any systems. So this is the only evidence which captures everything across the life cycle. If safety case is properly written and all evidence is captured, and ISA will ask those safety case. So everything what we mentioned, madam, it is covered in our safety case. That's all. Thank you.
Yeah. Maybe that I would like to add few more words to both of you. I will directly come to the answer which is asked by the question asked by the madam, that how to deal the non-conformances. Now, first of all, we have to identify what are the NCs, what are non-conformances, whether it is related to directly from the safety point of view, when it is audited by the, let's say, independent safety assessor, or it is related to the reliability point of view that will have an impact on my availability, which is known to only the organization. Okay, and where customer is ready to accept that NCs because it is going to have impact only on the reliability, not safety. And if let's say it is a safety related NCs or there is certain issues, now whether that again the analysis need to be performed, that based on which approach we are following. For example, let's say I am following the safe RAP approach. Okay, so in the safe RAP approach, I have to prove that the impact of that particular NC in terms of the safety. In terms of the safety, what is the cost? And then let's say I have to remove that NCs, then what additional cost I have to implement into a system. So that cost-based analysis need to be performed immediately. Okay, and we have to see that whether this NC is acceptable or not. So there are several ways, depends on what kind of NCs we have and at what level it is going to have an impact. And then accordingly need to be addressed.
Right. Yeah, just I give one example, like you have the Kavach system. Okay, and there is a safety case of a design safety case and certificate has been given. Now you are going to install at your railway. Okay, which your railway maybe their system sub definition etc. might be given. Now in this safety case you have safety this certificate, they are the SRX, safety related application condition, because that has to be made. Okay, say you have done the installation as per the requirement safety case, what is the things are there. When you are going for testing and commissioning, you find there are some are the things which are if it is a safety related thing, then you have to some restriction has to be put. So those NC, then what Mr. Hirala rightly said, at what level they are impacting. Okay, then if there is a intervention of a human required, then you have to give in your operational operational instruction training etc. you have to take care of. So what level of NC is there? If it is a design level then design has to be reviewed, means it is a redone. Okay, and because page has to begin, like it is a normal case in software etc. when they issue pages. Okay, but in case of hardware it is a complex situation when they have to go for EMC and everything, they have to do temperature etc. many things are involved. But everywhere, if this is not there, there are ways you have to degrade the things. Okay, and degrade things, sometimes you have to transfer those risks to operator. Okay, yeah, or maintainer, some other things. So this is how you will take care, and finally your product is accepted. And these are the conditions which will be written in your final safety case. कि ये काम करना है. Huh? This is how.
Before we conclude and propose a vote of thanks, because it was a wonderful session, may I request our eminent speakers to kindly switch on their videos so that we can take a screenshot of your presence.
Shall I start, sir? Yes, Balasubramanian sir, Shankar sir.
Thanks to all the speakers. Today's session was very insightful, and it is a step in the direction of having more discussion on RAMS in railways. Now I would request Dr. Swarnabai Arnikar to propose vote of thanks. She is Secretary, IEEE Reliability Society.
Thank you. Good afternoon to all. It's nice to be here. First, I like the ambience and good interactive on all the participants. So I'm privileged and honored to give this vote of thanks. First, I wish to thank Sri G.K. Dwivedi ji, PCST South Central Railway and President IRST India for co-hosting along with IEEE Reliability Society, and wish to thank he and his team here for all the logistics, for the VC facility and hospitality. And I wish to thank, we have a dynamic chairperson, sir, and he keeps even though we have official work, but still he keeps motivating us to do a lot of events. Somnath Pal sir, our chair, IEEE Reliability Society Hyderabad chapter, and our vice chair, Dr. V. Shankar sir, Professor Shankar sir, Vice Chair IEEE RS Society, and Dr. Anil Kumar and Dr. Ravi Kumar also. We have a small team, but our Somnath Pal sir is very enthusiastic. He keeps organizing. He keeps thinking how to make like safety and reliability to come into prominence in India, and people try to appreciate and then give its due importance, and appreciate the work of all the reliability engineers and scientists. And I wish to thank the speakers, eminent speakers. We had the welcome address by V. Shankar sir and the keynote address Sri Arun Saxena ji, IRSSE, ex-GM NCR. And we had Dr. Ajit Pandey ji, Head of System Assurance. His talk was very enlightening. And later we had a quantified RAMS talk by Somnath Pal sir. And post tea session, we had Rajesh Patel sir, and we missed Shinto Joseph sir. Maybe we can have it in the next part. And Dr. Hiralal ji, and all enthusiastic team, and and we look forward for more interactive and this one. And thank you, sir. Thank you for giving me the opportunity.
Here I would just tell one thing, that IEEE is extending full cooperation and promising that will help not only railways, every industry, domestic houses, even children's safety, women's safety in workplace. With all these things, we are working. And the day I took the post of chairman of IEEE RS, I told that my main ambition is to compete with China, because I'm fed up with insult from those people. I'm also member of Intelligent Transport Society. Every 3 months or 4 months that their journals, periodic journals are coming. I find that out of 70 authors, about 55 to 60 from China, very rarely 1 or 2 Indians, that too in Australia or US. So I am trying to inspire all the engineering students, go for research. Railway is having very much open space, and you need not worry about job in Indian Railway only. Indian engineers are very much appreciated all over the world. So whole world is there. And personally, I've got personal friendship with all the railway safety engineers of the world, and almost family terms I am having with everyone. I have got similar connections with a lot of universities also. So I want to bring, and today I am very happy कि राजेश तो मेरा ही स्टूडेंट था, ललित भी मेरा ही स्टूडेंट है, so they are just going so fine, and I am very much thankful that you have accepted my, I would not tell invitation, it is kind of instruction, Rajesh, you must take in this thing. Thank you.
I just want to add one point I missed to acknowledge Firdaus for conducting throughout the session. It was wonderful to appreciate.
Thank you.
So I, once again, thanks to Dr. Ajit, Dr. Hiralal, Rajesh, and Somnath Pal for making a just beginning of on this topic. And we wish to have much more detailed discussions on this because it is just a beginning. And a lot of detailed discussions are required. In fact, South Central Railway is conducting a webinar for our staff, officers, everybody for every day, every Saturday for 2 hours. So in that, we choose only one topic and only one speaker. So, and it basically quite interacting session kind of thing. So I wish to have detailed the sessions from all of you, and my request will be there. Kindly register it, and we will meet in future. Thank you.
Thank you, sir. We declare it closed.
Only attendance